welcome to the second day of the workshop of the Spoken Integrative AI within the FAIR project. Yesterday, I believe it was an interesting day. In the morning, we had a presentation about the scientific impact of the research that we do in FAIR, in this spoke. Some presentations were given by excellent, I would say, excellent young researchers who have been hired in FAIR. In the afternoon, we have a very interesting discussion, I believe, with companies. This is very important because also we discussed the role in the market that this company can have on a technology that nowadays we know USA and China, of course, are really investing a lot and providing incredible results. But there is still a market from them, from the discussion. And also we had an evidence that FAIR, in some way, provides a way to foster this, this market and social impact. In the second day, we will have the morning session that will be dedicated to our new partners. The University of Bolzano, Padova, Udine, Torino, and Verona with 2 different projects in 2 different departments. As I mentioned yesterday, this is the result of a cascade call for university. The call was launched at the end of the first year in December 2023. And we managed, this is a big result, a big administrative result, to complete all the process. So evaluation of the proposal, selection, contract signing by the spring of the second year. So all of them can start. I believe this is a very important section because it allows to join the force with the top-level excellent groups in different universities. And now I hand over the floor to Alessandro Sperduti, who will moderate very strictly, taking into account the time, this new section. So thank you very much.
In a muscular way.
In a muscular way, yes. Mi levo,
Perfect. I checked before and it worked. Okay. Okay. Now everything is okay. Okay, I'll do it right this way. Okay, that's more or less. Yes, okay. The problem is called MapSat, and the main theme is the design and implementation of solvers for computational logic and automated reasoning, able to take advantages of modern CPUs, so parallel devices developed initially for graphic processing and in the last decades used for more general purpose computations, as everyone already knows. Okay, the project started a bit later than the other, I suppose. We started in June for some bureaucratic problem. I don't want to go into details, and involves people from two departments of the University of Udine, from the Department of Science, let's say, and Computer Science, and Department of Engineering. Okay, so as I said, one of the lines of research consists in parallelizing basic tasks that you can find in solvers for computational logic. For example, if you think about a SAT solver or an ASP solver, an ancestor programming solver, which is very similar but a bit more tricky, you can find some basic functions, the one devoted to the learning, steps, the one devoted to the conflict analysis, unit propagation, and so on. And we want to obtain a GPU-oriented versions of these modules. Okay. On the other hand, we want to face another problem, which is the one of realizing, again, a GPU-based implementation of some other kind of modules that perform some sort of domain-specific reasoning. So, for instance, the decision procedures that one can use in SMT, or the propagators that one can use in CSP solvers, and so on. Okay, that's one. That's I would say the main stream of research of the project. And the aim is to use these modules, at least in two different ways. One is to obtain a toolkit of modules that one can use to enrich an existing solver, for instance, plugging in some GPU-based functionality, which could be seen as a substitute of the functionality of the solver, or a companion of that functionality, and the solver could decide at that time which one is better to use. And the final goal is to obtain a full-blown GPU-based solver for ASP initially, which in a sense includes a SAT solver inside, and an extension of a solver for constraint satisfaction problem using the modules that I mentioned before. So this is more or less the goals of the project. Okay, just a slide to rewind very briefly and very imprecisely what is a GPU. A GPU is a bunch of cores, thousands of computing units, to be correct, because there are not only cores, but there are other things that can that compose the hardware, and a hierarchy of memories, different kind of memories with different size, different efficiency, different pattern, access pattern, different lifetime, very different one from another. And this device is controlled by the CPU, which in the terminology given by CUDA is called the host, while the CPU is called device. And in the simpler interaction, the CPU transfers data from and to the device and runs computation on the device. That's the simplest way in which the two devices interact. Okay, the computational model is called single instruction multiple thread, very similar to single instruction multiple data, but a bit different because we have a number of threads executed by core, but each thread has its own execution context. So, in principle, they can execute different instructions. You can have 1,000 threads, each one executing a different instruction. Threads are organized in groups called warps, blocks, and grids, and each of them has its own peculiarities and synchronization and communication constructs, and so on. Okay, just another slide to single out what's the difficulty in programming this kind of devices. If one wants the maximal performance, has to adhere to some directives. The first one is all the cores must execute the same instruction. As I said before, this is not mandatory. But if you don't do it, you obtain serialization of executions, so performance decreases. Okay, so the idea is, if you execute on the CPU, be sure that many threads execute the same instruction. Okay, I'm simplifying a lot, so I'm not very precise in saying that, but just to give the idea. Moreover, we have a number of different kind of memories, And the way in which the threads interact with these memories is different depending on the memory. So we have different pattern access to be used depending on which memory you are accessing and so on. Different sides of memories. Different mechanism for synchronization and communication between threads, depending on which group of thread you are considering, warp, block, grid, and so on. Okay? So you have to take account of many things, and what turns out is that if you take a parallel program developed from another kind of architecture and try to run it on this device, probably you succeed in running it, but the performance will be very poor. Okay? So we have to face these difficulties. To realize the goals that I said before, we started working on this, and we obtained we made some initial steps. The first thing that one of the things that we did, and we are still doing, is the development of ASP SAT solver. We started from the analysis of what's on the shelf now, what are the state-of-the-art solvers, mainly for ASP, singling out what are the best use of memory, of the GPU memory to support the functionalities of these solvers, and started to implement. Okay, we are not we're not finished, of course, but the first thing that we notice is that there are two functionalities that in the standard solver, in serial solver, let me call them like that, are very efficiently implemented, which are the conflict analysis functionality and foundness enforcement for ASP, which are very efficiently implemented in existing solvers, but the algorithms that are used are not parallelizable. Okay. Still? Okay. So we had to develop a new algorithm for these functionalities. We are implementing them. Okay. On the other side, as regards CSP, we started developing a number of GPU versions of propagators for global constraints, for common global, very used global constraints. The first one we did was the cumulative global constraint. The trail we followed was to the same, look at the algorithm that exists for solving this problem, select, study, and design a GPU-based version of the best parallelizable option, do it, implement it, integrated it in existing CSP solver. In our case, we choose mini CPP, and validate, okay. For the cumulative constraint, we also have a result published on journal recently. And so it seems to work. So we started working on other constraints. We are completing the table, global constraint, the same sequence of steps, more or less. And we are also working on another constraint which is called the stable marriage global constraint. Okay. Also, this is being implemented in CUDA, integrated in the mini CPP solver. Okay, in doing all these integrations of propagators, we also developed a sort of uniform way of acting. So a uniform interface, a uniform recipe to follow. Very simple, actually. You have to produce two methods to handle your constraint. You can invent one, and then plug it into the solver, extending a syntax of the input language, the modeling. Okay, that's all. So you can do it very uniformly for various kinds of constraints. And we are, okay, refining this interface now. Okay, what is ongoing? I almost finished. developing the lines that and the things that I mentioned in the previous slides. Okay, so I don't read the lines, but this is the summary of what I've said in the previous slides and what we are doing now. Okay, and that's I'm done. That's all from me.
So while Padova, so Nicolò is going to prepare the presentation, we can also have one question. Can I ask a question while I'm moving?
Yeah. Here are the steps.
What is the speed up factor you got in solving?
It depends. It depends on the constraint, of course.
Okay.
I'm thinking about the CSP. Okay. It depends on the size of the instance that you are solving, and what turns out is almost the same scenario. If you have to do small, easy computations, it's better to do it on the host.
Okay.
Okay. If you have a big data to be crunched, then move it on the CPU. That's
Makes sense.
Any other question? No? Okay, thank you again. Nicolò?
Okay, good morning. I'm here presenting the project Symbolic Conditioning of Graph Generative Models from the University of Padova. The general idea of the project is to integrate domain knowledge in the broad sense, so in the form of constraints that can be expressed in many ways, in machine learning models, but in particular in machine learning models for graphs with a focus on generative ones. Our project relates, of course, with integrative AI in many ways. There is the idea to integrate AI with formal methods. I'm going to talk a little bit more about this later. Integration of domain knowledge, again, in many ways. In neurosymbolic AI, for instance, using knowledge graphs or exploiting large language models. And also trying to integrate constraints in explainable AI. Again, I'm going to talk a little bit about this later. This is the research team. So as you see, we are many people. In particular, we have 5 professors from Padova, of course, each one more or less with different competencies and background. And on the project, we hired 4.5 postdocs that started on the 1st of October. So actually, we started to produce more research since that day. So the presentation is organized in 2 parts. First, I'm going to speak a little bit about the theoretical contributions we are working on, and then I will try to present you the case studies, some of them if Alessandro stops me before. I will try just to give you the main ideas, hopefully trying to foster some collaboration. So if some of you is interested in some of these topics, either come talk to me, and there are actually many people from the project here, so you can talk to them. From the theoretical side, I'm going to present 3 ideas. First, we are working on some techniques to include constraints in neural networks in general, either in a hard or soft way. Then we are working on defining powerful graph neural models that can be used as a building block for generative models. And we also are working a bit on trying to identify some new formalisms to express domain constraints. So first about the inclusion of constraints in neural networks. So we are working on a project in which we are trying to enforce hard constraints in neural networks. So basically to produce a certification for the network to require specific constraints expressed in logical formulas. Now, this is a hard task because traditionally formal verification methods, they are able to tell you if a network respects or not a certain constraints, but not to fix it. So we work in this direction. So given a network, we are able to basically modify it in such a way that we can guarantee it respects a certain constraint. Now, here you see the details, but I guess I don't have much time to go in it. The core idea is basically we generate counterexamples using a constraint satisfaction problem properly defined, and then basically retrain the network iteratively until we converge in some cases, we can guarantee that we converge. Of course, in general, it depends on the property and on the network. Okay, this work is already published. Then, second theoretical part, graph neural networks. We are considering, so again, this is an example. We are working in a particular kind of networks that are called the CANs, Kolmogorov-Arnold networks. So the idea here is that these networks are not based on the, are not defined in the usual way, but instead of having nonlinearities on the nodes, basically we will learn the nonlinearities on the edges of the network, so on the connections, and the nodes are fixed, they just sum the inputs. Now, the very interesting part of these networks, so from the performance side, there isn't much of a difference compared to the classical one, but the nice thing is that the functions that we learn are actually univariate, and they're modeled with relatively simple B-splines. And so if there is a symbolic representation to learn, what we are showing is that these kind of networks are able to learn it. Now, this is actually what was already present in the literature, so again, I don't have time, but the point is that these kind of models are able to extract a symbolic formula. What we are doing is we are extending this idea to work on graphs, and in particular, on dynamic models on graphs. For the moment, we are working with a fixed topology where the label of the nodes change, but of course, the idea is to work on fully dynamic graphs. So we defined what we call a graph-CAN ordinary differential equation, where the idea is that we use these interpretable CAN methods to approximate a differential equation defined on graphs. For instance, for the moment, we are focusing on the Kuramoto model. And so, yeah, we can learn an interpretable version of this graph dynamics. Third theoretical contribution, so we are trying to, let's say, apply the category theory to artificial intelligence. So category theory is a very broad mathematical area, but what we are interested to in this project is that we can exploit this to force compositionality in different ways, actually. So on one hand, in the network design per se, so we can force that what the network learns is compositional, again, of course, if this is true for the domain. Or we can force it also in the explanation that can be generated for a particular model. So in the slide, you see a very simple example. So the XOR problem is, by definition, compositional with respect to the threshold function. So if we know this, this is the main constraint, and we can force it in the function, in the method we are using to learn the function. Okay, so now I'm going to present some case studies. Again, we are in a preliminary phase at this point. The core idea is to identify possible application areas in which using structured representation, so graphs, and constraints can make sense, can be promising. In this presentation, in particular, I'm going to talk to you a little bit about business process intelligence, embodied AI, and large language models, if I have time. So for what concerns business process mining, actually, there are a lot of possible applications. In this slide, I'm showing you a simple one. So the idea is that we have a data set of traces that are basically sequences of activities. And what we want to do is to do the data augmentation, for instance, if the data set is unbalanced. Now, the problem is that traces, so business event logs, are particular. And if you apply standard machine learning data augmentation techniques, they don't work that well. And the reason is that actually there are many domain constraints here that probably we don't know, but that actually exist for the model. So usual data augmentation techniques, of course, they don't consider them. So at the moment, we are working with an ad hoc approach, let's say, so an algorithm that starting from data generates reasonable, let's say, new examples. But the idea is that we want to be a little bit more general, so exploit generative models. and try to enforce domain constraints that can be either automatically discovered from data. For instance, that is declared that is a formalism that is used to express constraints that can be learned in a data-driven way, or provided by domain expert or being common knowledge. A second, so staying on the same domain application, there is another interesting application area that are called object-centric processes. So the idea is that traditionally in process mining, we are considering each process in isolation, but actually life doesn't work that way, in the sense that in the same company, different processing can be running at the same time, and of course they can interact with each other. For instance, the same resource can be doing 2 different jobs at the same time, and so of course this slows him or her down. So the idea is that we can model these interactions between different processes in order to basically better model the reality and so provide better predictions, for instance. So the graph part here is clear, and also the part with constraints, because also in this case we can include domain knowledge. Okay, also in the domain of process mining, we are trying to understand if including the domain information available in language models can help for in simple tasks of prediction. For now, we are considering them. The idea is that basically we can use language model to perform few-shot learning, like I said, for simple predictions models. And the idea is that this can help because in the processes, they are modeling real-world processes, and so we can have a description of each activity, and this description can be, for instance, textual, and so it can be exploited to include additional knowledge. Okay, a second application area is embodied AI. So in this case, we are working with robots, even though we are in simulations now. And in particular, a simple task is robot navigation. So basically, we have a sequence of a task that requires the robot to reach, for instance, different objects. The environment is not known a priori, so the robot has to move around and discover it. And the interesting part for us is what is referred to as social navigation. So the robot is not by himself, but it has to consider interactions, for instance, with other robots or with people that can be around. And in this case, of course, the constraints are clear because we have safety constraints. For instance, we want the robot not to hurt people in the house, of course. Or again, we can have external knowledge, for instance, on how to perform some tasks or some peculiarity of how to perform some tasks in that particular environment. In this case, graph representation is very helpful for having a high-level representation of the environment. For instance, topological maps. Yesterday, we have seen some works from the Spoke that worked on this idea. But actually, there are many ways in which we can represent the graphs here, because this kind of task involves planning. And so we can also use the graph to represent both the environment and the possible actions that our robot can perform to actually use real planners, and not just, for instance, language models. Okay, so I was quick, so I'm happy. The last application areas we are working on is trying to identify some limitations of large language models in order to, of course, try to improve these models using, again, domain knowledge or, in general, adding constraints. So actually, the focus here was to find some cases in which language models somehow failed for some definition of failing. And we started from a work done by our research group before for the idea. So the idea was that we noticed that the language model struggles to learn algorithmic procedures requiring propositional rules. So in particular, we now focused on the problem of formula simplification, so actually relatively simple. And the idea is that we are generating synthetic benchmarks to figure out what happens. And in particular, we identify two very simple cases that they don't require much reasoning, actually, but on which language models don't perform well. The first one is if we ask the model to change the priority of the mathematical operations. For instance, we say, OK, we have this equation. Please simplify it, but consider that the plus has priority over multiplication. As simple as that. And the second one is if we use non-standard operations. I got some examples now. Identify the problems. We are now starting to work on some solutions. The simplest one can be few-shot learning, so including some examples in the prompt itself that can work somehow, but not that well. Or, of course, fine-tuning the models. So I conclude the presentation with a couple of examples of this. So on the left, you see what I was mentioning. I'm telling the model that I want the plus to have priority over multiplication. But at the bottom, you see that even though actually the output, in the output, the model seems to have understood, in practice, it didn't. So on the left, you have a mistake. On the right, instead, you have a similar example in which we are using one-shot learning, in this case, with the structure of the example we are providing being the same as the one in the formula we are requiring the model to simplify. So the nice thing here is that the structure of the equations that we are providing for few-shot learning has a strong impact on the model performance. So this is something worth further research. And this is another example with non-standard operations that in this case are defined as tables, and basically the model fails to look up at the table. So I want to conclude just with mentioning some future research directions we are going to pursue. So apply category theory also to explainable AI, extend our certification, network certification framework to consider reinforcement learning, so not start from a fixed network, but also learn it by reinforcement learning. Work more on defining expressive graph neural networks and try to include them in diffusion-based graph generative models.
Right.
And of course, to extend the case studies. These are the ideas, but now we want to actually include the domain knowledge and the graph models in them. Okay, this is all. Thank you.
So is Marco here? So please come here while, if there is any question to Nicolò. No questions? Okay, thank you. Since we don't have much time, I guess we can go forward.
Thank you. So I'm going to report about the project MyPM, which stands for Multimodal AI Techniques for Process Mining. The notion of multimodality is a sort of rephrasing for integrative AI techniques for us. Since I don't know how many of you are familiar with process mining, it was mentioned in the presentation before, I want also to give you a brief overview of what is going on in that field and how this connects to the project and to integrative AI. Oh, sorry. Don't know what is happening.
The term process science was coined recently. There is a very interesting position paper that was published this year in the newly established Journal of Process Science. And if you look at what is going on there, there is finally a combination of what we were used to call business process management on the one end and process mining on the other hand. So there is the idea that we have to capture processes in an organizational setting in order to represent what is happening inside the company and how the company organizes internally the work. And this is the realm of business process management, where you typically elicit these processes and then you want to manage them. More and more, while we execute these processes, we are collecting data, digital trace data about what is going on, and that is where data-driven techniques come into play, where you want to analyze this data and provide insights about the actual execution of processes, which is called, when the data have the form of traces executed during the execution of processes, is called process mining. So this is the BPM life cycle, and if you look at what is going on here, there is a process discovery phase where you want to elicit these processes, then you model them, you configure information system to support the execution for the domain experts and the workers of the company, and then you have the actual execution. And there are, again here, two important pillars that we are obtaining. On the one hand, we want to make explicit descriptions of these processes, and on the other hand, we are collecting execution data about them. So let me go a bit more into details. So what does it mean to elicit a process model? It typically means you do conceptual modeling in an organization. You have process analysts that go there and talk to different stakeholders in the company. And what happens is, and that's one essential feature also of this process, often when we talk about processes, we talk about diagrams like BPMN or that capture the control flow of what is going on. But if you think about it, even if you have a focus on the process, there are many other dimensions or perspectives that are coming into play. There is, for example, here the data perspective. So processes operate over objects that have mutual interrelationships. And often all this complexity is simply stripped out and you only focus on control flow, assuming that you have some notion of object that you are not going to describe further. You can see here in the top left a decision diagram. You have decisions that are taken, and these decisions are taken partly based on the control flow, what you did in the past, but partly based on the attributes that these objects carry. So you must now be able to integrate perspectives. And then there is the point that obviously, as I told you before, you are executing this process in a real organizational setting. And if you imagine that the process is nothing else than a compact description of everything that you want possibly to see in the organization, separating it from instead what you don't want to see, then you can imagine that executing this process essentially means taking choices and evolve these objects over time. For example, I'm managing orders. Each order will take a route in the process, will have a different speed, decisions will be taken, and different ending states will be reached. And so here there is another perspective that comes into play, which is time, and is also how you are modeling the fact that, for example, in what I was showing here, some cases all ended up in the same state, and one ended up in another state. You may simply model this as non-determinism, or you may want to go more into quantities here, and, for example, introduce a stochastic perspective that helps you understanding which are the iros in the process and which are instead the parts that are not very often executed, right? This all brings to this notion of multi-perspective processes that are at the center of this project, right? So we have a backbone perspective, which is the control flow, but then we have these different types of data that may use different theories. We may have real numbers, we may have a relational database, we may have whatever complexity you can imagine, and there is this framework of reasoning modulo theories in AI that is crucial here. On the other hand, there is this perspective of uncertainty that may have, for example, to deal with modeling decisions stochastically, modeling the duration of activities stochastically, but we are also looking into other aspects, like, for example, fuzziness, different types of probabilities, etc. So one of the first main questions of the project is how to represent this formally, right? considering the case where the backbone in terms of control flow is a Petri net, which is the reference formalism for representing, so to say, procedural processes, or if you want to work on declarative, declare was mentioned before, there are linear temporal logic on finite traces and variants of these logics that are the foundational basis of declare. And then we want to have techniques for model analysis. So reasoning, dealing with these different perspectives. Then there is the second pillar, right? So there are the event logs. So let me go briefly through those. What are the types of data that we are interested in process mining? The time dimension is essential, but we don't have like time series, at least, to represent the execution traces. We may have time series to represent connected phenomena. So we essentially have data like those that you see here. These are data from a triage in a hospital. And as you can see, what we are collecting here is what are the activities that are executed, when they are executed, by whom these events are generated, and on which objects this is going on. So for example, this case ID that you see here, this may be the patient identifier in the hospital. And why is this so crucial? Because if you now join all the events that deal with the same patient, you can see the trace of the patient through the system, right? And so we have, again, here multiple perspectives that are coming into play. There is time, there is different types of data, there are objects. And for standard processes where you can imagine that every object is evolved in isolation, there is a standard by IEEE to represent those. But reality is much more complex than that. So the community had a recent shift, which was also recalled before. It's typically called object-centric process mining or object-centric process modeling, where if you consider a large variety of processes, you never have single objects that are evolved in isolation. Objects are all interrelated, and the interrelationships may be of a very complex nature, like, for example, many-to-many. So you don't have anymore that an execution focuses on a main object. Every execution focuses on a collection of interrelated objects that are co-evolved. So, for example, you may have one order that has multiple items. Each of these items is packaged with other items that may belong to the same or different orders. So there is the problem of how to represent this complexity. And then also, when you approach the problem from the data point of view, there are different forms of uncertainty that you have to be able to represent. Here you see a probabilistic form of uncertainty, like some event happened, I'm sure that the event happened, what I'm not sure about it is what was the activity that was executed. And you may want to, represent this probabilistically, like, 70% chance this was a accept order, 30% chance this was a reject order. And I'm also not sure exactly about the timestamp. Okay, so that's a type of uncertainty you may want to capture. We also looked recently into another type of uncertainty. It is also very relevant to try to interconnect these kind of reasoning techniques in a neurosymbolic setting. What if events have instead a fuzzy nature? So you see here a person that is doing two things at the same time with different intensity, right? You may want to capture here, look, the person is more focused on cooking, but the person is also working in parallel, like he's having a call while he's cooking, okay? So the type of uncertainty that you have here is not the type of uncertainty that I mentioned before. So you have now to deal with fuzziness and probabilities. Process mining is meant to connect the two, right? And that's where we are in the core of the project. So if you go back to the origin of process mining, it was really, I want now to connect these process models with the event logs. And what is that you want to do in particular? You want to automatically discover process models by looking into this data. You want to be able to generate new traces, but looking into the models once you customize them on top of the data that you have observed. You want to be able to enhance the description of the models by using information that you have from the data, like, for example, again, frequencies and times. But you also want to accept the fact that reality may deviate from the models, and so what you want to do is conformance checking. You want to identify if you can replay the data on top of the model, and if not, where are the deviations and where they do not agree. And what we are doing in MyPM is approach various problems in this spectrum, not with ad hoc algorithms, but by resorting to different AI techniques that are combined together. Okay, so that's the core of the whole project. Now, I mentioned these process mining techniques, but you may even go beyond that, right? So you may want to focus not only on what happened in the past, so data that you collected about past executions, but also try to suggest things regarding the future, right? Like what is likely going to happen? Can I give recommendations on how to operate on this? And that's where also other techniques, mainly from machine learning, come into play, right? Like predictive analytics. So I want to conclude in the last 3 minutes by giving just some highlights on technical things that we are doing. The first is providing new models that extend LTLF on the one end and standard Petri nets on the other to be able to represent these different types of data, how they interplay. And there are various complexities here that emerge because, for example, when you are in a situation where one order has multiple items, you may want to progress the order in its life cycle only when all its items have progressed. So you need also advanced forms of synchronization that are not covered by contemporary models. And as I was telling you, we want to reason on these models. So an approach that we are applying here is behind the scenes encode everything into SMT. So you get logical formulae that are representing the execution semantics of these models. And one main focus that we are having in the project is in particular use SMT to solve these conformance checking problems. So you encode the specification in SMT, you encode the trace that you're observing in SMT, and you frame the problem of trying to align them as an optimization modulo theory problem. And you can discharge these to solvers. We are doing pretty much the same, considering forms of uncertainties. So here you see a Petri net with stochastic components. So when you take a decision, you have a stochastic variable that is representing that. And there are various queries that you can pose over these models, like what is the probability that a trace is going to be produced by the model, or give me all the traces that together cover 50% of the probability space of the process. And to solve these techniques, behind the scenes, you typically need to resort to model checking on the one end to deal with the time aspect, and Markov chain and related techniques to deal with probabilities. This is also in turn relevant for conformance checking. So an interesting feature is that reasoning here provides also core components for doing process mining. If you have this uncertainty coming into play, and you have your process coming with a distribution of probabilities, for example, over the traces, you may take a log, look into the frequency of traces that you have in the log, and then try to merge the two, right? So you try to basically compare the probability distributions and get a form of what is called stochastic conformance checking. Last two highlights. On the data part, there is an ongoing effort to define a new standard for representing these processes executions where you don't have traces anymore, but now you have evolving objects. And there are various approaches here. One is called event knowledge graphs, where the focus is now events refer to multiple objects. We must be able to represent this. This is not able to describe, though, what is the actual impact that these events are having in terms of the objects. Like, when I create an order, I'm instantiating a new object of type order. And when I'm canceling the order, I'm destroying certain relationships, right? This is instead very widely studied in databases. For example, now there are formalisms like temporal property graphs, where you can represent how objects and relationships evolve. And what we are trying to do is merge these two perspectives together in an integrated representation. Last highlight that I also want to emphasize, I think is particularly important, not only for the topic, but also because it was already a fruitful collaboration between Bolzano and FBK. So this is joint work with Andrei Buliga, Chiara Ghidini, myself, and Massimiliano Ronzani, is entering more into the neurosymbolic aspect of some of these process mining tasks. And one task that is very relevant is computing counterfactuals, because you want to explain about certain phenomena that you are observing through the data on the one hand and through the model on the other. The problem that you have there, which was also mentioned in the previous presentation, we may have background knowledge that we want to incorporate. So give me a counterfactual with all the characteristics that a counterfactual have, but make sure that this counterfactual is obeying to some background knowledge that is expressed, for example, in LTLF. Now, there are various techniques to do that. We wanted to have a technique where this is guaranteed logically, so not only probabilistically. And so what we did was combining techniques based on genetic algorithms to generate counterfactuals, making sure that looking into the background knowledge and extracting information from the automata that we can build given an LTLF formula, we could only allow the genetic part to mutate things in such a way that the background knowledge is respected. And this is going to be presented next month at AAAI. That's pretty much what I wanted to say. Thank you.
So please, the next speaker, questions? Can you tell us something about the complexity, because you are, I mean, working with many objects simultaneously, and so this is going to be a problem, I guess. Meanwhile, if you leave
sure.
the stage to...
So essentially, the way we approach these problems is like these problems are not only very complex in general, but many of the things I showed you are completely undecidable. So the idea is first we try to characterize the more general setting, and then we go deeper into fragments. And we are trying to find fragments where we can say more about the complexity, but also fragments that even though the complexity is still quite terrible, we know that these solvers go quite fast, right? Is a bit, if you think about SAT, right? There are many instances where even though we know they are NP-hard, SAT solvers are very good. This is like lifted now to the first order. So SMT solvers go quite well in many settings that, you know, complexity-wise are quite terrible. So there is also a lot of experimentation that we are trying to do to confirm or disconfirm this. Okay. Yeah.
Thank you very much. So Riccardo.
Okay, so good morning, everyone. So this project is about the integration of AI techniques and tools into a robotic platform, in particular in a semi-autonomous surgical robotic platform. So robotics is per se a multidisciplinary area, and if you add also the AI, then and the complexity increases a lot, so that's the reason for which you see a lot of people here, experts from robotics, AI, computer vision, and also we have a professor in moral philosophy and a professor in philosophy of law, just to have everything in a single shell. So I will start first showing our experimental setup. So what you can see here is a Da Vinci research kit. So it is a surgical robot for a minimally invasive surgery, and we have on top right the surgeon side, so where the surgeon controls 2 joysticks, and the big picture is the patient side. So now we have a mannequin, and usually there is an assistant surgeon next to the patient. What we want to do is actually to substitute the assistant surgeon with 2 robotic arms holding standard laparoscopic instruments. So, and the goal is actually to design the overall architecture in order to understand the procedure, understand what the surgeon is doing, in order to help him or her in, since there is this gender balance, so we have to pay attention now, how to proceed with the procedure. If there is an assistant surgeon, then people call this kind of architecture solo surgery, because you need just one surgeon. And in order to do that, we have to integrate a lot of technology in terms of perception, the environment that is changing over time. We have to develop modules for the situation awareness and the decision making to help a surgeon with the right action, in the right time, with the right instrument in the right place. And then when you have this decision to automatic plan the task and of course deploy it. So these are the list of objectives that we have in this project. Of course, we don't start from scratch. We have a lot of results from a previous European project that ended a few years ago. We are just refining and improving the architecture that we already have. So the goal, in particular, the goal in this project is to improve the detection of laparoscopic and robotic instruments using the video streaming from the endoscope, the phase segmentation of the procedure, because this is a key information to, that you need in order to know what to do next. Then continuously update the model of the anatomical, the 3D model of the anatomical scenario, because of course during the intervention the scene changed completely with respect to preoperative information. And then to provide new, a better human-robot interface to the surgeon, developing new tools. And what we are tackling right now is the knowledge representation. This is actually a very important and quite difficult task. So we have to integrate the preoperative knowledge with actually what we collect during the intervention. And that is actually quite demanding, because based on this knowledge representation, then we have a good or a not so good decision maker. And then at the end, we plan to have a sort of white paper on the ethical aspect and on the legal aspect. So we started from the mechanics, I would say. So I know probably you are not much interested in this part, but in order to execute some task in an autonomous way, you have to bring some sensors closer to the instrument. So we designed smart surgical instruments. So these are some of the mechatronics part that I can skip. And I would like to show you this video. So one of the first tasks that we are tackling is to autonomously select the proper tools and change the tools. Of course, the position here is known. What is not known is the position where we have to insert the tools in the belly of the patient. You see that there is that plastic, white plastic. This piece of plastic is called trocar, is from where the instrument enters into the belly of the patient. This is not known. So we have, thanks to the camera, to detect the trocar, to detect the belly of the patient, and then to plan the trajectory in order to insert in the proper way without harming, of course, the mannequin or the real patient. And so these are the kind of things that we are working right now. So you see there is the integration of a lot of standard robotics with a lot of computer visions. But that is not, this is not enough, and because of what we want to do is also to plan the trajectory in order to satisfy what is called the remote center of motions. So this is the trocar from where we insert the tools. But of course, you have to pivoting around this point. You cannot translate, otherwise you harm the patient. And so, since the position of the center of motion is not known, we have to identify, to detect it, to estimate it, and then to plan the trajectory for the robot that move the tip of the tools where you want, without, satisfying the remote center of motion. And so, this is the standard architecture that we are defining. So you see different controllers according to the phase of the procedure. And this is standard robotics. Now, where the AI came to play, the first thing is about the phase segmentation. It is clearly important to know in which phase of the procedure we are to make the right decision in order to help the surgeon at the Da Vinci console. And this is not, of course, a new topic, but in the surgical domain is quite challenging. There are not a lot of data set, and what we are planning is also not only to detect the current phase, but also predict the next phase, because sometimes the phase changes because we are, with our autonomous tools, to change the phases. So it is a little bit different than the usual problem. So these are our architecture that we have developed. At the moment, we are working on a data set on called cystectomy, because it is available. There are a lot of annotated data, but the procedure we are focusing on is the prostatectomy, where there are no available dataset. We have our own dataset with a few procedure on real patient and on mannequins. And the last point is actually the more important. So the phase segmentation or anticipation must be done in real time, take into account that in some cases is the autonomous system that triggers the next phase of the surgical procedure. So it's not just a passive analysis of the video streaming, but it is a little bit different. Another thing that is very important is the tool segmentation. We already have algorithm for the semantic segmentation of the anatomical scene, so to know what we are looking at. But also what we want to improve is the tool segmentation that is needed to understand the scene and of course to localize precisely the tools. This is the classic picture for automotive, and what we are doing is the same things in the surgical scenario. We are using SEM2 in order to detect the different tools, in particular the tools that the surgeons is moving, so not the one that we are controlling, because of course we know where the tools that we are controlling are. We don't know where the tools that the surgeon is moving, where they are. And so this is what the techniques that we are developing in order to know where the tools are and later to predict where they will be in order to avoid collision with our tools. Another things mainly related on computer vision is on the estimation of the trocar, so this piece of plastic. And this is quite important, rather important, because when you know the pose of the trocar, we know also the direction for the insertion of your tool. So you have to integrate a lot of 3D pose estimation, and another key aspect is the end-eye calibration. So integration of where, the frame of the camera with the frame of the robot in order to insert accurately the tools. So, as I said, we are working, colleagues are working on the ethical and the legal aspect, and we discussed a lot yesterday about all the legal implications about the AI in industry, but of course it is even more important in the healthcare domain. And I would like just to highlight a couple of things. We have to understand in particular how autonomous or semi-autonomous systems interact with the medical personnel, and in order to be sure that our algorithms are reliable, trustworthy, and explainable, the standard things. And we follow here a bottom-up approach, so we are planning to deliver a sort of survey to surgeons in order to understand their needs and how they see this kind of technologies. From the legal aspect, this is even more important, in particular on the attribution of conduct and consequent responsibilities for the subject, in this case the surgeon, conditioned by AI and conditioning AI. So this is another quite interesting area, in particular now that there is the AI Act that appeared last year. And okay, so I don't want to, in the interest of time, I don't want to go on with this detail that of course are not my topic. I would like only to read the third point. So the complexity increases when technology intervenes between a person action and the result, making it difficult for the patient to prove harm of negligence. So when everything is almost autonomous, for a patient it's not so clear if he has to sue the surgeons or the company that produced the robot. So, and this is quite, quite important. Well, so in this slide, just the impact that we expect. I will only to focus on the third one, on research. So most of the technology that I saw yesterday and also today can be applied on a system like that. So if you want to try to implement your techniques in these peculiar scenarios, we are more than happy to work with all of you. The next phase are to improve our situation awareness and decision-making module, and to describe the knowledge in a much more efficient way that we have right now using state chart, and of course developing a better human-robot interface that not only provide force and visual feedback, but also speech recognition and augmented reality features. And that's all from my side. Thank you.
So while Vittorio comes to change, okay, there is finally a real question.
So meaning the other were not real? No, just a quick question, but when you use the Da Vinci, you have a localization system on board for all the links, right? So why can't you get the information of how it is positioned directly from the encoders of the system and with kinematics, etc.?
You can do that if you have the Da Vinci research kit. So in the lab, you can do whatever you want. If you register all the robots, the Da Vinci, with your own robot, that is fine. But this is actually what is not going to happen in real life, because in the operating room, you don't have access to this data. The company doesn't give you access to this data. So you have to estimate the pose of the instrument by using the only thing that you have, the video streaming. So in the lab, you can do what you mentioned, but we are planning, to do something more ambitious.
Okay, thank you very much. Let's go forward. Vittorio.
Okay. Good morning, everyone. This is actually, I'm presenting my project, which is a joint work between me, Mashid Shiri, and Chidem Beyan of University of Verona Department of Computer Science. So first of all, we want to describe in a few slides which is our project, which is called TALIM, Transfer Adaptive Learning in Perfect Multimodal Data Scenarios. Essentially, we start from the consideration that so far AI systems, or let's say much better, deep learning techniques are good when we have large, well-annotated data. But in reality, what we have to deal with in the real world are often imperfect data, which means that the data can be unlabeled, can be partially labeled, can be noisy. I mean, in terms of labels, can be just a bunch of data, or also class imbalanced, or even worse, having some bias. So one can say, okay, you can annotate this data, but annotation is costly and error-prone. And of course, costly because billions of data cannot be annotated manually, and also if you use automatic techniques, they are not quite, reliable. And the other consideration from the other side, I profoundly believe that if you have to deploy an AI system in a real application, it's not a good idea to deploy just using a single sensor, in a way, depending on the kind of applications. But if you think, for example, autonomous driving, if you can base only on cameras, could be in the limitations. So we want to push forward the idea to have multimodal data to ensure a reliable and stable goal fulfillment and behavior. So a multimodal artificial intelligence system can, in a way, try to cope in a better way with more flexibility and more reliability over a larger number of applications, enhancing the robustness. So the objectives of our project is just to investigate in multimodal learning through the lens of imperfect data. And more technically, what we'd like to explore is a set of self-supervised learning methods for model pre-training and leveraging multimodal data. we want also to address transfer learning and domain adaptation tasks in multimodal setting. These are actually quite, I don't know if you are familiar with transfer learning, domain adaptation, domain generalization task, maybe more later. And also distillation paradigm, and especially using teacher-student architecture, trying to evaluate the importance of different multimodal data streams. So to give more importance to one data streams over another depending on the specific task we have to solve. As a whole, our idea is to try to focus on data augmentation, especially also data generation, to cope with data imperfection. So what we want is essentially try to control the generation and augmentation processes to improve the task performance. And yeah, the idea is essentially to, the main strategy, the overall strategy is trying to understand how to control these data transformation techniques or even generate suitable synthetic data to correct or rebalance the problems derived from the available data sets. So in this context, our work is essentially try to address a self-supervised learning approach based on dual contrasting learning loss based on CLIP architecture. So for many of you, probably CLIP is not familiar, but essentially is an architecture, is a technique which is trying to pair image and text data. And we also address this domain shift, adopting techniques called adapters and learnable prompts on this CLIP model. So this is actually the outline of my presentation. I try to introduce first the task, which is medical anomaly detection, and then some explanation of the data, and a few information about the proposed method and a couple of results and conclusions. So let's start from the medical anomaly detection. This is actually is becoming a big problem. It's a big problem. It's becoming much important lately in these last years. So it consists essentially in identification of unusual patterns in medical data. This unusuality, this abnormality is essentially a challenging task because you can see, for example, from the example here on the left that you have a normal image, and you see, anyway, a pathology on this image on the right, which is quite different. So you have to understand if it is a pathology with respect to the normal organ you can see here. But if you, anyway, see on the right, this another, for example, signals, which is essentially a signal can be heart rate or whatever. This is actually the normality, but in the plots below, you can see some noisy signals, which essentially is the same, a little bit more noisy for whatever reason, and this is much different. So it's really an issue to understand which is an anomaly and not confounding with some noisy behavior of the signal you are trying to acquire. And even worse, if you have to deal with a few shot means that you don't have this large amount of data, but you have just a bunch of data, for example, 2, 4, we arrive at 16 and no more. And this is actually even a worse situation, in the sense that you want to identify these abnormal patterns in the data, having the availability of a limited labeled data for normal and abnormal. In some cases also you have only normal data. So you have to infer in some way which is the abnormality with respect to the few normal data you have. If you think at the biomedical or healthcare applications, you can think essentially that we are in this condition. So we can have potentially many data for the normality, but abnormality could be also not so common, let's say fortunately. So there is this class imbalance between normal and abnormal, considering abnormal, for example, as a pathology. If you are inserting in this reasoning also the multimodal, we want also to generalize over multimodal data, which means that we have to deal with different modalities and try to detect the anomalies depending on the modality, or let's say independently from the modality. And the different biomedical data we can have is just a difference in appearance, structure, imaging across the various modalities. Again, this is actually regarding the nature, the very nature of the data, but if you are going to the anomaly, we can see that, for example, there is not only one type of abnormality, it can be also different types, and we have to generalize this behavior from just a few examples. In some cases, you can have access to auxiliary data sets, but also in this case, these auxiliary data sets are not enough to improve the performance. So in the end, our approach one approach which is dealing with multimodal, few-shot medical anomaly detection task should address this data scarcity, taking to generalize and to cope with variabilities to have these robust solutions and flexible, depending invariant to modalities and type of abnormalities. This is an example you can see here, and for example, from the first two rows in the top are normal images, multimodal. And you see, for example, here you have some MRI techniques and CT. You have here the retina. This is histopathological images, which is a CT for the chest. And you see this normal stuff. You see very different part here between the two. And if you go to the last row, you can see here the abnormalities. And the abnormalities you see, depending on the modalities, are very different each other, depending on the task. So we have to deal with also different anatomical regions, because we have brains, we have liver, we have retina, we have cells. And for this reason, we have to, in a way, ask some help, and in the last years, the help and the support we can have in this kind of models is about the text. So we want to leverage visual language models, and so we need some sort of textual annotation, language annotation of abnormalities, but also in this case, the definition of abnormalities, the textual abnormalities, is not so easy to make, because the abnormalities also from the point of view of textual information are not similar to each other. So that's why we wanted to leverage a visual language model, and we use some this clip-like architecture. The clip architecture is interesting because in trying to pair textual and visual information, and especially it is trained on a very large number of images, natural images. So we have to, in a way, transfer this knowledge acquired by these natural images to biomedical domain, multimodal. And another task is that in this case, for the clip case, the images are essentially at object level, so they are trying to pair foreground object versus the textual information. But in our case, we have, in a way, not only object abnormalities is localized, but can be also distributed, so it's this kind of problems. So our proposal is essentially to have this two-branch architecture based on adapters for few-shot anomaly detection and segmentation also. And we introduced this another loss function which takes into account image text learning, and we are introducing an alternative loss to try to cope with these problems in a classical benchmarks. Let me, in a way, just go through quickly to the kind of data. We have here liver CT, so computed tomography, brain MRI, histopathological images, X-ray of chest, and this, the last one in the bottom, are retinal images. Previous work, I will skip because it's not so important, but this, let's go to the main, the core of the work, which is essentially using vision adapters and learnable prompts in the context of your bench architectures. So the vision adapters, you can see here the architecture. So on the top, you have this vision encoder and the text encoder, which are frozen, which are pre-trained. This is actually the encoder text and vision from CLIP. And the text encoder is taking an input to the normal and abnormal prompts, and produce embeddings which are inserted in these CL modules, one for each level of the vision encoder. These CL are contrastive learning modules which take in input not only the embeddings from the text but also the embeddings coming from the vision encoder from the normal, yes, this one, and the abnormal cases. So N stands for normal, and AB stands for abnormal, and A stands for adapters. So the idea is to trying to leverage, so to learn the learnable prompts, which are this V and W, separated between normal and abnormal. And also we took also the adapters, which are anyway, I tell you in a minute. Try to put all together, try to pair in a proper way normal and abnormal prompts, learnable prompts and embeddings from the visual information, aggregate in some way to give segmentation and classification results. Why adapters? Adapters are simply very tiny neural networks, and they are used to customize vision language models to a new task, to a new application without retraining the entire system. And this is actually why we use this, so we try just to learn from the adapters, and then the learnable prompts is essentially included to align the prediction with domain specific of the biomedical domain. And this is also important for transfer the clip potentialities to the specific domain of biomedical segmentation, that multimodal biomedical segmentation and classification. These are the contrasted learning. Essentially, we have this matching between the adapters, normality, considering also the visual information, and the T is the textual embedding. And the contrastive is between this normality and the abnormality between text and images. And also, we have the abnormality branch, which is doing the same, but the opposite sense. So we are trying to match the abnormality together and try to get far away from the normality stuff. So in a sense, this is actually trying to match the normal and abnormal behavior, trying to localize exactly the embeddings and improve the information. We combine these two results, and we aggregate in a multi-scale aggregation in order to have, and we learn on the basis of this two-branch architecture. This is the clip loss, which is essentially the loss based on clip, the classical one, and then we add other two terms, one for classification, which is simply the cross entropy, and instead for segmentation and classification, we add two classical other losses, which are the dice loss and the focal loss, which takes into account the imbalance of the data classes. And that's it. So this is the results in classification and segmentation. AC stands for classification, AS for segmentation, and we have the beta results, which are at the bottom here, also compared with the state of the art. And this is also the results in average concerning, and we have also the 2 shots, 4 shot means that we are still using just 2 images for normal and abnormal. That's why it is quite impressive that the results are so good with just very few information. And then Alessandro is in a way. No, the conclusion is that, okay, so I try to, we worked in this clip-like architecture for anomaly detection scenarios with normal and abnormal data. We leverage on this. We have an overall improvement. And for future work, we are now trying to address the cross-modal scenarios. So far, these results are in a single, in a way, unimodal stream, but for all the data. Now we are trying to understand if the information coming from other multimodal data streams can help to the anomaly detection of others. So this is called the zero-shot scenarios. And also we want to leverage a generative approach to synthesize abnormal samples in few-shot settings using only normal data. So we want, in a way, generate abnormal data in a controlled and more automatic way to improve our performance. That's it. Thank you.
Okay, so is there any question while there is the switch for the final presentation? So you could also use, I mean, there are approaches using Q-former. It's basically similar. What is the main difference? I guess the contrastive.
Sorry. I'm not so familiar with Q-formers. I know they exist, and yeah, maybe we can have a look to see what happens there. But this is based on linear architecture, which was used in this way. We try to adapt it in a way. Let's say fine-tune the performance based on this clip architecture. Yeah, Q-former, yeah, I know the existence, but sorry.
Okay, thank you. So we go to the final presentation.
Thank you. Okay. I'm going to present very quickly the project Harmonia, which is focused on developing, I don't know what's happening. Okay, perspective taking. Is there something? Okay.
We were thinking that you are going to fix the problem. Okay, so it's the adapter thing.
Is it the adapter? Okay.
So meanwhile, who was losing this? Is it yours, Vittoria? No? Okay. Lost.
Okay, maybe it's working now. So yeah, about developing knowledge-enhanced perspective-taking large language models for inclusive decision-making. In this project, which I'm coordinating, we have a multidisciplinary team, including people of different groups from University of Turin, and in particular colleagues from my department, computer science department, covering different competencies from natural language processing to semantic modeling, and colleagues from the Department of Economics and Statistics, which are especially interested in behavioral phenomena related to, in this case, to urban spaces. And we, thanks to the funding of FAIR, we also had the possibility to hire a junior team of researchers, mainly postdoc, and one PhD students to support our activities. Basically, Harmonia is focusing on the goal of contributing to rethinking relationships between citizens and public administration. This is our main focus. And in particular, the idea is to rely on the use of large language models, but working on enhancing them with relevant knowledge for supporting informed and inclusive political decisions in public decision-making processes. And in particular, the idea is that there is a need from the stakeholders' perspective about understanding how to use such a very powerful technology in order to improve decision making, and especially making it inclusive, and especially because a good policymaker usually address this task trying to understand from many kind of data that are available to the city halls, for example, how to improve, for example, a service, taking into account that there are different community needs from different categories of citizens. So our aim basically is to leverage this very large set of heterogeneous data coming from also opinions that citizens are expressing on social media, but leveraging also data which are usually the ones exploited by policymaker in order to take a decision about how to intervene for improving some services. And the idea is to understand how to exploit also a new approach which are studying in Torino, which is called data perspectivism, in order to develop large language models which, informed by this data, are able to somehow adapt the suggestion to the policymaker with respect to the needs of different populations, with the idea that somehow an inclusion, the decision-making process must take into account that given some kind of discomfort signal that can be detected by the policymaker, it is possible that different perceptions from different categories of citizens, like women or men, if we think about gender, that could have different behaviors and needs with respect to a service that can be related, for example, to mobility, and or other people which, for example, is retired, can have different perceptions about the service and different discomfort, and also the stakeholder that must intervene with the decision making, trying to change something, can take into account all these different data and the different perspectives in the decision. So there are mainly two objectives in the project. One, it is related to the interaction with the city hall of Turin in particular, in order to get information and data about verbal and non-verbal citizen interactions with urban services, in order to have a base of data about behaviors, social issues, and also possible nudges to change behavior. And to model all such heterogeneous knowledge and making sense of this heterogeneous knowledge by exploiting semantic modeling, basically. And so in the first step of the project, as we will see in a moment, the key points were the identification of some case studies together with the City of Turin City Hall, and the part of semantic modeling, which will lead to the creation of a knowledge graph that will be released at the end of the project. Then there is the other part, which is more related to the development of these large language models with perspective taking, which will leverage on the information collected in the first part, and with the idea that such perspective taking large language models will reflect different communities' viewpoint, and the idea, we are already exploring a different approach in order to inject knowledge in large language model in this perspective, in particular retrieval augmented generation approaches, and we plan to investigate also more sophisticated knowledge injection approaches. Of course, there will be also a part of evaluation that we will be of the outcome of this enhanced decision making, that will be taken together with city councillors that were that we were contacting in the last months, and that are happy to be involved in order to evaluate the usability and the reliability of the technologies that we will develop. And also it will be interesting to see how this new methodology to enhance the decision making will lead to results different with respect to what we get by using, for example, standard econometric modeling, which are the methods exploited by our colleagues from Department of Economics. About case study identification and data collection, I would like to just to share that we had contacts with different departments of City of Turin, in particular assessorato alla transizione ecologica, digitale con delega ai trasporti, parcheggi e viabilità, so Department of Transport, and assessorato al welfare, diritti e pari opportunità, so Department of Equal Opportunities, and we also had had data from a regional school office, and in the end, after all these kind of discussions with these entities, we decided to focus on a main core case study, which is public transportation in the city of Turin, even if we collected data also on educational services and public housing in order to have also interesting intersection on other kind of service that can be provided and enhanced by our system. About data collection, which has been driven by the choice of these case studies, we collected data about the interaction between citizens and urban services, in particular in relation with mobilities, in order to develop a map of possible discomforts that we would like to address. And these data are heterogeneous. We were identifying some social media sources that could be interesting from this point of view, like we were collecting data from Reddit, Facebook, and Twitter about urban services related to mobility, housing, in particular in the city of Turin, in order to have a kind of social sensing about these issues. But we collected also data from the department that were involved in that are involved in the project, in particular behavioral data, statistics, census data, and also textual data in forms of complaints of the citizens with respect to the services that we would like to improve with our with the help also of our tool. About semantic modeling, we are in the process of developing a semantic model in order to integrate all this kind of information, also trying to catch different perceptions and opinions of different categories of citizens on services that we want to improve. And this is just an example of these perceptions can vary, like having an overcrowded bus in the morning can be highly problematic for high school students and not problematic at all, for example, for retired people. This is just a simple example of what we can model. And another activity was related, since our decision maker will interact with LLMs in Italian, there is the issue of what is the state of the art of the kind of model available with respect to interacting with the Italian language, which is something we were working also in the context of a benchmarking initiative. And I would like just to mention the Calamita Challenge that was that I participated to this kind of benchmarking activity, which is supported by our Italian Association of Computational Linguistics. And I participated also to another initiative in collaboration with SPOC2, in particular with the group of Bernardo Magnini, in order to create a benchmark starting from adapting shared tasks that were built in the past in the context of the Validità evaluation campaign based on native datasets in Italian. And This has been something to be done in order to understand which kind of LLMs we will use among the available ones, which are the more promising, just to give an idea about the kind of mapping of abilities that we are doing in these benchmarking activities. That there are many different abilities of large language models that can be involved, and also related, for example, to gender gender fair languages, which is something that we tested also together with a group from FBK. And you can take a look about all the kind of tasks that have been, for example, evaluated until now in the context of these evaluation campaigns. The other point, as I mentioned, is the innovative point is to test in this kind of application context the perspective approach that we are trying to follow in general in Turing, both from the point of view of natural language understanding, but in this case it will be interesting to test the possibility to develop this kind of approach in a natural language generation context in order to try to make the model capable to support policy decisions with a kind of point of view informed by the different different shaping that we will have with respect to categories of citizens. Just a very quick overview about the pipeline that we are following concerning the RAG approaches that we are testing. One of the point is to use to make sense of this heterogeneous data, and I will say just something in a second. This is just a sketch, a kind of possible scenario that you can imagine to deal with our kind of approach. So, for example, a policymaker could need to reshape a line of a bus for part of the rules, and can interact with our enhanced LLM in order to get suggestions, considering that maybe he wants to know if there are already categories which are of citizens which are releasing a signal of discomfort, and maybe in changing this route he would like maybe to favor such categories of citizens which are at the moment disadvantaged, or at least want to be aware about the possible pros and cons that comes from different decisions that can be done. And the idea is that all the information that we collected about mobility in the city and about perception of citizens with different belonging to different categories can be exploited by the retrievers, and in order to inform different large language models which enact as, let's say, different categories of citizens in terms of encoding their perspective in the suggestion that will be delivered to the policy maker. And this will allow, hopefully, the policymaker to orient the decision that in a way that improves the comfort of a citizen, or at least it will be bigger awareness about which categories of citizens will be advantages by certain choices, for example, also in a simple case like changing the route of a bus. And decision making is never one size fits all, and the idea is that also in the communication of these different possibilities, it will be possible to explain in a transparent way also to the policymaker which were the data that were exploited in order to orient a given suggestion, and also maybe the language of the explanation could be tuned also in terms of gender fair language, if this is something which is of interest of the public administration. Just a final word. Actually, we are working on the issue of making the heterogeneous data homogeneous, and one approach that we are testing at the moment is verbalization, which seems to be quite a promising way to try to make the data that we have, which are not only textual and verbal, verbalized, in order to have also the possibility to have a better comparison across different kind of data that we are trying to use in this kind of project. And thanks, and sorry if maybe it was taking a bit too long. These are just some first results that we're publishing in different venues in computational linguistics.
Thank you. So any question to have? Okay. Wait.
Okay. Thanks a lot, Viviana. Quick question. So clearly you can have, let's say, different needs and different perspectives, exactly, from the different stakeholders. And so the idea is that then the decision maker is left to find a synthesis, or the approach is also helping, for coming to a solution that is the one solving the problem for everybody.
Yes, the idea is that in the end, the answer is a kind of reasoned summarization of all the possible support that can be enacted with pros and cons. In my opinion, but maybe just my opinion, it's a bit dangerous to leave, something more to the machine. I would like to have the decision maker able to be supported by this kind of summarization of all the possible perspectives, but I would like to have the decision maker able to decide in the end with these materials, probably with better awareness anyway of what are the pros and cons, and explanations of which kind of data somehow that were available and that are injected into the model can be used. Because my impression is that sometimes there are many data available to the ones that must take the decision, but it's difficult also to know where they are, how to access them, and then there are maybe many mediation steps usually in this process. Maybe something like that can help the decision maker to be more aware about all this stuff, but in my opinion it could be nice that then they take the decision maker, which is not maybe a single, but a team of people, take the responsibility to decide what to do.
Okay, thanks.
Okay, thank you again to all the speakers, and I guess we are ready for coffee now. Thank you. And then Paolo will will bother you to finish with the coffee and starting with the new session.
Ah sì, qua c'è l'HDMI. Faccio un test a vedere che succede, perché questi affari sono sempre misteriosi. Ah, forse dalla regia devono... Ho 20 minuti, no?
Così acceso, così aspetta.
Okay, I think we can start. Okay, so welcome to the session on that focus on AI and agents embedded in real world. So I think this will be a very interesting session in which we have 3 talks. The first one is by Giovanni De Toni from Fondazione Bruno, Kessler, University of Trento. So Giovanni, you have 20 minutes.
Okay, so good morning everyone. I guess you can all hear me. Today we're talking about mostly collaborating and, let's say, contesting AI, AI applications, and the research we'll be doing about these 2 topics. So most of us have seen, let's say, the tremendous impact of AI in our society, in many fields, decision making, medicine, etc. But there are also, let's say, we've seen also like potential bad effects of AI in the context of, let's say, fairness, in the context of bias, especially in, again, decision making applications. And that showed us how we should like tread carefully with these technologies in general. And I usually like to start with an example about what I mean by all of this, by bias and unfairness. Imagine that there is like this Alice who's trying to apply for a loan at their hometown bank. And the bank uses a very good black box model to understand, let's say, if Alice is worthy to be granted the loan or not. And as it works, Alice sends her application through the system, and the decision-making model, AI-based model of the bank, answers by telling Alice, okay, actually we cannot really grant your loan application because of some reason, because of the system decided that you are not worthy to get, you are not trustworthy enough to get, let's say, your loan application granted. And unfortunately, Alice usually has no real mean to understand why the decision was given and let's say how to possibly improve to be granted a loan eventually. Funnily enough, why fictitious, this example is not that fictitious, because there are, in the news, there have been examples of, for example, people being rejected like from mortgage application because of, let's say, AI system used by, for example, the financial institution. For example, this is like an example of Crystal and SKS from the US. So this is actually something that can happen and happens nowadays. In the past years, because of these issues, there have been many laws have been, let's say, developed and studied. For example, the AI Act, the GDPR, the California Consumer Protection Act, I think, that should, let's say, prevent or like protect like users, final users, from this harmful behavior of these systems. And one safeguard that gained traction in the past years, which is most interesting, is called algorithmic contestability, which basically is the idea that we as people should be able, let's say, to contest and, let's say, have the means to challenge the decision taken by decision systems. Okay, but in as many laws, they don't really define how can we operationalize this kind of notion of contestability. And we look at this problem, let's say, with the eyes of machine learning researchers. So, you know, in my research and our research, we try to, let's say, provide a feasible path towards contestability by using actionable explanations. To provide actionable explanations to people in order to let them know how to understand why they were given a certain decision and how to act in order to improve their outcome, for example. In the case of the Alex example, that would be for giving, for example, a recurse recommendation that tells, okay, if you had increased your income by 3%, then we would have given you the loan in a counterfactual fashion. So in this presentation, what we mean by explanations in general, we mean, again, counterfactuals. And just to give you, let's say, a very brief walkthrough of what a counterfactual is. Imagine our standard scenario in machine learning where we have features and we have a target variable we want to predict. In this case, it's binary, so either you get the loan or not. Then imagine that we have a classifier which is approximating our, let's say, posterior distribution, let's say. Imagine also we are given a function, a distance function, a cost function that tells us how two individuals are like far apart, for example. And all this problem about, let's say, contestability in general, giving counterfactual explanations for these kind of scenarios boils down to solving these equations in which we want to find the minimal changes you have to do to your profile in order to get a different classification from the one that you were actually given in the first place. Pictorially speaking, this means that, for example, if we are classified, this is the decision boundary of classifier, if you are classified in the blue area, which might be, let's say, the bad area where we won't get our low application granted, we want to move to the red one. So through diverse potential paths, and like C, B, and D could be, for example, counterfactuals. So where you would end up, which are the changes you have to make to your profile in order to get like, to the red area, which is the good one in this case. So in this, in the past years, let's say, we started to think about developing, let's say, a pipeline to operationalize, let's say, formally these notions. And we're going to cover in this quick presentation all these aspects. We believe that first we need to learn how to explain certain part of the model, the decision of a model, geared towards, let's say, this context of contestability. Then we need to transform these explanations into recommendations in the form of tailoring them to the user needs, okay? And then there must be a step of like evaluation and deployments of these technologies to understand how to improve the first two steps, okay? And we, let's say, published several work about these topics. So the first part, we're gonna like see very briefly, is the idea that we need to find, let's say, counterfactuals given a black box model. Okay, we need to find, we need to solve find ways to solve the previous optimization problem. And in our research, we view this algorithm contestability task as a sequential decision-making task, in which the user has to take several actions in order to change the outcome of the classifier, and therefore we developed a method called FAIR, which incorporates a discrete set procedure and a reinforcement learning agent to learn, let's say, and amortize the global policy to generate counterfactuals actionable for, let's say, for users, where the actionability notion is described by our, let's say, our cost function, our distance function. Again, we evaluated this with, let's say, synthetic scenarios by looking at the validity, which means how many times our counterfactuals actually change the outcome of the classifier. And with respect to our other competitors' models that were available some years ago in the literature, our approach is, achieves, let's say, a higher validity, let's say, and also, since we are learning a policy, we are providing an amortized method that requires far less queries to the, let's say, underlying black box classifier of the bank, for example. Since most of the previous competitors were directly optimizing, solving that optimization problem for every user. Moving on, we then thought about, let's say, personalizing this kind of counterfactuals, because the idea is that maybe users have different requirements and different preferences about which action they can actually perform. For example, you can imagine I'm able maybe to increase my salary by 3%, but some other person or people could be more. It could be easier for them, for example, to lower their debit, their monthly spending. Okay. So for this second part, we devised this the first, let's say, human-in-the-loop algorithm to implement this kind of algorithmic contestability. And the idea is that we employ an interactive procedure in which we elicit user preferences in order to tailor the counterfactuals to your own profile. Okay, so they're not like general counterfactuals, but they are tailored to your preferences and to your actionability requirements. And to do so, again, we explored some techniques about, let's say, Bayesian inference and preference elicitation to account for example, uncertainty over the user answers and so on and so forth. To give you an example, this is kind of like the pipeline. So we show certain recurse recommendation or counterfactuals to users. The users picks the one that they prefer the most, and we keep like iterating this loop until we hit, let's say, a query budget. And again, like in some simulation experiment with realistic data, we saw that by interacting with users, we can actually get lower costs. I mean, counterfactuals that achieve the same validity, but which are considerably cheaper with respect to the other competitors, which do not incorporate the user within the counterfactual generation process. So once we have done the first two steps, we then thought about making all of these techniques, let's say, easily accessible from a user perspective. And therefore, we focused on, let's say, we devised and created an interface where users can actually interact with this contestability algorithm in order to discover counterfactuals that can serve, for example, this interface, for example, could be given by the bank to tell the user, I can give you certain plans you can follow in order to be granted a loan on your next application. And again, in our scenario, we did, let's say, a small pilot study with simulated credit lending tasks, in which we evaluated the effectiveness of this kind of like guided style recurse interface, where the user is guided towards a counterfactual, versus a more exploratory interface, where the user actually has to find the counterfactual manually, without any help from the decision maker. And again, we get some results that, okay, people thought this guided style paradigm was actually pretty useful, but they also enjoyed, for example, being able to discover counterfactuals manually by themselves. And so these results could be very useful also to improve the first two steps, or learning to explain and the recommendation, because they tell us what actually user really needs. In the as the last part, one of the latest work, we instead thought about a more, let's say the robustness over these counterfactuals over time, because when you deploy these techniques, you want these counterfactuals to be robust to user execution, but also to potential, let's say, trends. Okay, I'm going to explain more clearly. Basically, when you apply counterfactuals, when the users start to follow your counterfactual suggestion, it's going to take time for him to do that, because I cannot really increase or decrease my salary overnight. So I must be sure that between the point I give the counterfactual and when the user apply again, he must be still able to get a positive classification. Okay. So we, let's say, studied this task through the lens of causality, and the problem becomes, let's say, generating counterfactual for time series. So you can see on the graph on the left. So given that at time t we got our loan application rejected, what are the actions we should do to get our loan application accepted at time t plus whatever 2, 3, n? Okay. And in our latest research, we show that actually most of the counterfactuals methods for algorithmic contestability and recourse are not really robust to time. Okay, and they're pretty fragile, especially also robust counterfactuals are fragile to time. And let's say the only way, let's say, to solve this is to try to employ at least an estimator of the, let's say, stochastic process about how a user evolves in time. And which actually is also an important point to improve these methods before deploying them actually, let's say, in real life scenarios. So this first, let's say, very quick part about, let's say, contesting AI. We identify, let's say, several potential pitfalls of these methods anyway, or desiderata that are not satisfied. Usually, for example, counterfactuals are given ex post, the decision is taken. So if an unfair decision is taken, okay, the counterfactuals happens already when the decision is in place and is affecting, for example, a person. And in general, the problem that we have, for example, fairness or lack of accuracy, etc., sits within the decision subsystem itself. Okay, so counterfactuals and algorithmic instability is something that mitigated these issues, but it doesn't really solve it for good. So what we would like to achieve, apologize, what we would like to achieve are, let's say, guarantees over these models. Okay, guarantees of accuracy or fairness, or in general that if we use a decision subsystem based on AI, it should complement, let's say, human expertise, provably in a way by design. So we shifted a bit in the last months or so, and we started to study how to design systems that complement human expertise, provably by design again. So consider like this very simple task in which I have decision subsystems that helps a human expert decide, for example, a disease given an X-ray. Okay, and usually the decision subsystem we have now works more or less like this, where the system gives a prediction, or maybe gives also explanations, calibrations, scores, probabilities, etc., etc., and then the human expert has to factor in these informations to define, make a decision. Okay, for example, maybe this guy has pneumonia. However, these systems implies that the human has to build a good sense of when to trust the system, okay, and how to incorporate the system prediction into the decision-making process, okay. And there are very conflicting studies about which are the tools, which are the things the system should provide, and which are the effect on the final prediction, okay. So there are, let's say, conflicting studies on which are the best, let's say, output that the decision support system should provide. We instead moved towards, and we studied a different kind of support systems that used something called prediction set, where instead of providing, let's say, explanations, probabilities, or calibration scores, etc., we output a set of predictions. Okay. And the funny thing about this, the important thing about this prediction set is that you can build them with coverage guarantees through uncertainty quantification techniques like conformal prediction. For example, we can say, I can give you a prediction set where the true label is contained within this prediction set with a bounded probability. Okay, so probability 1 minus alpha. And this is actually a theoretical guarantee. Okay. So in one of our latest work, we studied, let's say, how can we construct this prediction set in a way to maximize the human accuracy in the end? Okay, because we can. We want to build these systems, this prediction set, in a way that the human benefits the most out of them. And this is represented by the problem on the bottom left side. Unfortunately, we found out that this problem is actually NP hard and NP hard to approximate, which means that there is no really, let's say, good solution that can work for all, let's say, all possible models under the assumption of the human being represented by a multinomial logit model. But however, we found out that we can actually build a greedy algorithm that can give us performances which are, let's say, equal or greater than, let's say, conformal predictor. So we can actually build a system that complements human expertise, preferably by design, in an efficient way. And we do, and let's say our algorithm works because we are able, let's say, to generate prediction set in which the labels inside confuse the least the human. Okay, because if in a prediction set there are, for example, two diseases which are very close, very similar, or where the human confounds them a lot, okay, then the human will not be able to. I mean, we might be confused by the outcome of our decision support system. Okay, that's mostly it. All of this research was possible thanks to wonderful collaboration with a lot of people here. Some of them are here in the audience, here at the University of Trento and the Fondazione Bruno Kessler. And that's all from my side. Feel free to ask any questions.
Yeah. Questions? No question? Okay, so so when in the decision process you explained at the beginning, I guess there is a yes or no decision, right? So, but is always the case? I mean, usually we need the support system that help us to take a decision, comparing different factors, and somehow may happen that also other parameter can be brought to the decision maker by the user itself, no, the client, in that case, that can somehow move the decision in one direction or the other. So I guess.
So one potential, let's say, we were discussing with some financial institution partners, let's say, and they told us that sometimes there is a loan officer that takes the decision in the end. Okay, so maybe mediated by certain systems or whatever. So there is a human actually in the end taking a decision, maybe helped by the decision support systems, and in that case, let's say a counterfactor would still be useful because it could, let's say, help the user maybe. Okay, this is your profile. Okay, maybe you can implement a simulation system in which you say those tools, for example, that tells you, given this profile, maybe we won't give you the loan. We're not sure because then there is a human decided in the end. But if you were to improve your profile this way, then your chances to get the loan will improve. Okay, when you end up talking with the loan officer, with a human, okay, which will use my prediction.
But I think that it's possible to think a system that acquire new evidence from the client and actually may also change the outcome of the decision.
There is a very, let's say, understudied area which is called participatory classification, in which they try to do that. So the idea is that I want to create a set of, say, classifier with monotone accuracy in a way that the more information I give to you, the more, let's say, I will be correctly classified. Okay. but there is still, I think, nothing that works towards.
Because I was thinking that, especially in the domain, the medical domain, I mean, more evidence can be available when the decision has to be taken.
There is something that we're actually working on at the moment, in which you can build this prediction set by. You need, for example, usually a physician arrives, I mean the patient arrives and he has no feature specified, and the physician can ask, for example, for exams, okay? And you need a way, let's say, to tell the physician, okay, you should do these exams in order to maximize your accuracy in the end, okay? Because if I tell you, the decision support system could tell to the physician, you should do these exams in a way to maximize the accuracy and to maximize your predictive accuracy on the disease that this guy will have. So it's kind of an interaction.
Okay. Is there any other question, Giuseppe? Yes.
So,
wait.
So when you talk about counterfactuals, this is a very evocative term, but you know, the guy that didn't get the loan, you know, imagine if you get the answer, well, you just go and get a higher salary. Do you think this would be a valid solution to your algorithm?
I mean, most of these things.
So the issue basically is that when you frame the problem like you did mathematically, there is something missing, which is the set of valid solution for that individual. I mean, otherwise, it's not counterfactual. It's a nice mathematical problem.
Okay, usually the set of valid I mean, this is something that usually should be discussed with the stakeholders. For example, there are certain features which are not really actionable. So you should, let's say, avoid changing certain features because they are not like, if I tell you should get younger to get your loan, it obviously is impossible, it's not actionable. And the second part about maybe increasing the salary is not valid for a specific user. This is something that we deal in the second, with like the second project, in which we have this interactive framework, in which a user can actually tell to the machine, look, for me it's very hard to change my salary because I don't really have the capacity now. So give me another explanations. I mean, this is something that actually don't really, maybe you can see it here, okay? But I mean, I don't really have it at the moment, but here I mean, on the three boxes with the values, those are the counterfactuals that tells you, oh, you should like do this or that. If you click one of those in the interface, there is also, let's say, a slider that tells you how easy it is for you to do that. Okay. So if you keep doing this, okay, in the end, like the system should understand, okay, you cannot really do that. I mean, this person is not able to change his income. So I need to find a different counterfactual with different actions, which might not exist also. That's another problem.
That's very likely. Also, I don't know if you've done any user study, but even if you expose a subset of solutions, that could have an impact on the workflow, because the person may be, for instance, let's say, insulted by the ones that you propose, so that it just stops right there. So that's when you go to the user side, okay? But I think, you know, thinking about having this other constraint.
Okay, Massimo.
I don't want to start a discussion, even if it's very, very interesting. But we have actually some results in the next talk, together with you.
This is not fair. Okay, anybody else? Okay, thanks Giovanni for the nice presentation. And now, Luigi, you want to come? Talking about AI in the real world, I think robotics, it's
Okay, so I will talk today about embodied system, which is one of the areas where the FAIR project has delivered some of its results. In particular, it's the object of one work package inside the FAIR framework, whose overarching goal is to enable system to operate in the physical world, in particular in connection with robotic systems. So, what makes robots so special? Why should we devote a special attention to them? Well, the most evident nature of robots is, at least of contemporary robots, is that they operate in open environment. They have to respond to unexpected events, and they have to deal with the most unpredictable entity in the world, which are human beings. So this makes some difference with standard AI systems because they have, when you are developing an intelligent robot, you have to take into account such issues as safety, guaranteed level of safety, real-time responsiveness, explainability. Here in this case, explainability takes also special meaning because people tend to distrust robots, right? So the fact that the behavior can or cannot be explained is something that really goes at the heart of their acceptability. And finally, last but not least, robots are supposed to live in a social world and abide by the same rules, written or unwritten, as we humans do. So given this context, our work has been developed along two different prongs. The first one is to develop a methodology of general applicability. And in this case, the methodology hinges on a mix of model-based and learning-based approaches because they are both needed for reasons that will become apparent in a few minutes. It has to be flexible and evolvable, and at the same time, it has to retain adequate level of explainability and safety, as I just said. And then what we also did is to put our methodology to the test of reality and try to confront ourselves with some concrete use cases, and some of them I will talk about later on in this talk. So let me start from the methodology. Now, consider a few motivation examples where our activities as humans typically unfold. Some of them managing a warehouse, building a complex, I don't know, in this case construction, applying a medical protocol, interacting with our humans. There are a few traits that these applications have in common. And the common characteristic is that the fact that we are able to execute this activity is based on a narrative. This narrative can be formal, like written documents, or informal, like observations, pieces of information that we collect during our life. We take this bunch of information, we take this narrative, and we transform it into knowledge base. This is a very computer science term, but knowledge base means a place where this information is stored and becomes usable and actionable. And at times, as I say, the narrative can come from written reports, well-structured. Other times, these reports are not so well-structured, but the information is there nevertheless. It's just up to us to be able to extract it and make a sense of it. Okay, now let's move a little bit to robots. The big questions that we have dealt with in this methodology are, how can we generate and maintain a knowledge that we derive from this type of source? How can we make a good use of this knowledge? And then, in the future, how can we update the knowledge learning from experience? And what we are thinking of is place where this knowledge is stored in a way that it's understandable to human, explainable, and it's also shareable and reusable for future purposes. Okay? So what we will look at in a few moments, and we will also like to have a scalability, of course. We will propose a framework where this knowledge is generated. It is transformed into planners, planning activity, and we can also leverage from our experience and learn from it. And finally, we can think of probabilistic and semi-probabilistic extension. This is a nutshell our workflow, the one that we have developed for this work. Our starting point is, as I said, a very narrative report. In this case, we have worked with natural language written reports that can be evaluated by a large language model and transformed into a knowledge base. This knowledge base is a logic knowledge base expressed in a logic language, a very famous one, Prolog. Then we also combine this high-level knowledge with a low-level knowledge that expresses what each and every resource that we have is able to execute. And we are able to do some consistency check prior to sending this technology into the real world in action. And then, based on that, we can generate a logical plan. In this logical plan, we can extract those elements that can be parallelized, and then we can optimize the execution of this plan with our resources, and finally generate what is called behavior tree, which is something that is amenable to execution. So this is a very toy example. You see, this is our narrative. On the left-hand side, we have a high-level description of our goal. On the right-hand side, we have a low-level description of the capabilities of our system that somehow refines them. Then we have a very nice button. We press it. And what we come up with is this knowledge base after a few iterations, because there could be cases in which there are inconsistencies, but I will skip this part. And then we come up with a knowledge base in which we describe our initial state, our goal, our actions. And then what we do is to also extract a low-level knowledge base in which we detail how our specific robotic systems is able to execute these high-level actions. And then what we do is that we generate a sequence of actions that we call a totally ordered plan, out of which we extract a partial order plan. So we single out those activities that are really supposed to be executed before each other, and others that can be parallelized, and then we implement and we produce a behavior tree. This behavior tree is directly executable. This short clip show, in this case, the narrative was just how to put two blocks one on top of the other, and this is what we did. And the entire flow was started from our narrative, and we came up with this execution of this thing. We have also worked on a probabilistic extension. In this case, we work in the same way. We create our knowledge base, but this time, instead of generating we generate a Markov decision process. And I would like to show you an interesting application of this. In this case, we have a human, and we are supposed to help the human. What we do is that we put some blocks in an order, and this order is supposed to nudge the human into executing its task, the castle, in this case, building castle, in a pre-specified order. So we would like to proceed layer by layer. We don't impose this thing, but what we do is that the way we arrange the blocks in the table, putting some closer, other farther from the humans, somehow induces this type of behavior. And finally, with 2 or 3 of my students, it worked. But this is interesting in its own respect, and we are we are still working on this. So there could be alternatives. Yes, we could generate directly the code, but in this case, the granularity of what we generate is too small for us to make a sense of it. We could generate PDDL instead of Prolog, but PDDL doesn't have the same ability of Prolog to reason about, make inference. And thereby we have decided to have this intermediate abstraction layer where it's possible to include such things as the affordance of the objects and what is possible to do, etc., etc., and make a pre-reasoning before moving on to the planning phase. Now let me move to another example. In this case, it doesn't have to do with the direct application of these techniques, but it's interesting nevertheless. In this case, the example is inspired to Industry 5.0. So we have a case where the robot and humans are supposed to work in close collaboration. So our problem is how to make this collaboration safe enough. What currently happens is that whenever a human comes too close to a robot, the robot slows down very much, and this can preserve the safety, but of course reduce productivity and have some price to pay. What we can do is to act proactively, make a prediction of what the human is going to do, and try to adjust the plan of our robot so that a situation where the robot is comes too close to the human and we have to slow down never happens. Okay? And how do we do this? We start from the video stream, we extract the skeleton, then we execute motion prediction. And we have experienced two different alternatives, one based on graphical neural networks and the other is based on more standard regression of GMM. And then based on that, we move entirely to the world of model-based approaches. We apply model predictive control or time the A star to make changes. And this is the result. Now it's, at the moment it's just simulated, but we are already collecting the experiments. There were some details to fix with the camera arrangement before being able to replicate this in reality, but we can see that the robot, whenever the human makes a motion that could create collision, the robot detects this problem and walks around by making a change to the plan. Okay. Finally, I would like you to show, and this, in my opinion, this is a very good example of mixture of model-based and learning-based approach, because we use learning-based approach to extract the skeleton and also to make prediction of the motion, and we use model-based techniques to execute our prediction. Our planning. The second example I would like to show has to do with ultrasound imaging, okay, so ultrasound diagnosis. So in this case, this type of diagnosis is very good because it's possible to extract a lot of useful information without interacting, without invading the human body, because we stay outside and it's perfectly safe to do this. But the problem is that it has to be well done, right? Because the data resulting from the diagnosis are highly subjective because they depend very much on the skills of the operator. So in this case, it's a lung ultrasound, and it is important that we maneuver the probe so that we remain in the costal gaps, in the gaps between the two ribs. Otherwise, we don't acquire the correct images. We should also orient properly the machine, okay? And another thing is that we have an obvious shortage of operator that is slowing down the possibility of having this precious and important exam. And so what we can do is trying to do teleoperation, but teleoperation in a way that is guided by the system, so that we avoid problems related to the distance, and we also avoid problems related to the lack of experience of the operator. So the first thing that we do is that we have a perception pipeline. In this case, we start from a segmentation. We construct our point cloud, and based on that, we construct a model. There are very good tools based on machine learning to do this. There are very good tools also to construct models of the skeleton. And what we did is to take these two models that can be constructed by simply taking some view of the person around, and then making a procedure that fits very well one into the other. And it is interesting that the results in terms of physiological distance of the bones that we measured afterwards were amazingly close to the real numbers, right? And it's interesting because this type of result is completely non-invasive. But the interesting thing is that once we carry out this result, we deduce the position of the ribs. And this position of the ribs can be used as a guidance to execute the exam. And what can we do? What can we do? In our case, we used a technique in robotic that is called virtual fixture. So in essence, you have a point that is moving, you have an ideal point, and there is a control algorithm that makes it so that you don't go astray too much from the real point, from the desired point, right? And so in some sense, it is possible to guide the person so that he or she, the operator, so that he or she remains within the gaps between two ribs. Now we are experimenting even better alternatives that allow us also to control the orientation of the instrument, but this is ongoing work. And this is just an example of what we did. As you can see, we have a remote station, and we have the robotic station, and then what happens is that we use the rib that we estimated to guide the exam, so that the operator succeed in following the right position in the rib cage, in between the rib cage. Okay, let me just draw some conclusions. Intelligence in robots is a fascinating and it's very challenging field. There is a bunch of new techniques that have come up, like deep learning and large language model, that allow to think what was unthinkable just a few years back. But these techniques have to be used with some grain of salt, because when we move to the robots, it's important that we make things in a guaranteed and in an explainable way. So it's inevitable that we come up with a kind of mixture of model-based and data-driven approach. So if we had to summarize in a sentence what we are doing, is that, okay, learning is important, but you don't need to learn what you know already. Right? So just concentrate the learning part on the things that you don't know, please. It's not useful at all to rediscover the wheel, right? Let's try to understand what to do with the wheel. Okay? And I think that stops my talk.
Time for questions.
Thanks, Luigi. It's very fascinating, and I think that there is one aspect of robotic that you have touched in your presentation, that is these aspects of being aware in the world. I was referring especially in the one that stops when the person is nearby, or even this last one.
Situation awareness.
Yeah, it's partially is situation awareness, but partially is the awareness that you are part of the world. So
sure.
Even when we are distracted, we don't bunch against the wall.
Yeah.
We are not situational aware,
Yeah.
but we are aware that there is a wall. So it's a little bit different. In psychology, there is this idea of embodied cognition. I wonder if you think that these aspects of embodiment is something that can be applied or is applied in robotics. And how do you feel about it?
Well, it's hard to say in general. I'm just if I think I got your question, but I'm not sure.
It's not a question.
There is a theme here in which once the robot interacts with the human, also the human interact with the robot. Okay, so what we didn't see in the video of the human-aware motion planning is that when you take your decisions, the human behaves accordingly. We kind of pretended that everything kept going as if we were not present. There are other models in which we are working, in which we saw the closed-loop interaction between human and robot. This is called, you can use game theory for that, or opinion dynamics. I have a student who is working on opinion dynamics. You create a kind of awareness of how you change the environment, and the environment is changed by you somehow.
No, that's certainly a point. My point was a little bit different, even if your aspect is very interesting. Now, my point is that in your approach, it seems to me that you try to get everything back on reasoning, or some aspect related to reasoning.
Yeah.
While for human beings, it's not everything about reasoning. Sometimes it's also...
A small thing is about reasoning, in fact.
Yeah. And so what I wonder, is this model based on analogical response more than reasoning in logic,
so
is more or less
you mean
probabilistic?
if we are trying to build something like an emotional aspect in robotics?
Yeah, there is this theory.
There are people who are working
that emotion has this part.
But the problem is that conflicts with the very nature of robots, because the robots are supposed to be predictable. And the only way to make a robot predictable is to make it reason. If we make it feel things, it can be nice to interact with, but not necessarily predictable. It's just a matter of setting priorities.
Okay. Anybody else? Yes.
I have a question about your knowledge base, the one you talked at the very beginning.
Yeah.
How do you update or change the knowledge base? Because it is not so easy. I mean, to me, to change the structure and include other knowledge, and without tampering on the what you already know to do, what to do. And if you add something else, maybe you can damage the overall structure. What kind of check you have to put in place?
Yeah, let's say that the advantage of having a logic-based knowledge is that it's in some sense compositional, right? When you learn new facts, you just add new predicates or theorems somehow, right, about how things are done, without necessarily impairing the rest. And it's important because this allows you. Okay, when you learn things, you start doing stuff, then you encounter a situation where you didn't predict, or your robot doesn't behave as predicted. What happens is that you can transform it into a new piece of knowledge, into a new predicate. When this happens, don't do that, right? And then you mix it up with the rest, and when you generate your new plan, you incorporate these pieces. Yes, there could be a point in which things becomes, let's say, unmanageable, because you have learned too many facts that are contradictory, and so you end up not having solution for your problem. This is a possibility. But per se, the logic nature of the knowledge base makes it upgradable with new facts.
If you want to include a task that you want to perform in a better way, so it's not just composing something else, but substitute a piece of your knowledge.
Yeah. Okay, what we did is that we have this decomposition between high-level knowledge and low-level knowledge. High-level knowledge is how you get things done in abstract terms. Low-level knowledge is how your concrete robot does it, how you can refine your actions. So it's just a matter of replacing your low-level knowledge with something different.
Any other question? So I have one question. Actually, I would like to try to make a connection with the Giovanni talk. So is there any need in robotics to explain the decision of the robot to humans in order to improve or in order to justify what they have done? So,
but you mean in real time?
Yes.
Never thought of it.
But do you think that this could be
I think I think
to kill you because I don't like it.
I think it could be okay. What we are working on is a kind of non-verbal coordination, right? In some sense, what the pose of the robot suggests what the robot is going to do, and vice versa. If the interaction becomes more complex, like with visual elements, with a piece of synthesized voice, etc., so that you can have a more sophisticated exchange on what is your intent, it's something that we haven't yet investigated. But for sure, of course, it could.
For example, when the robot has to decide which plan to use in order to achieve the goal, I guess.
But I see it in a different term. So take, for instance, a collaborative task. A robot and a human collaborate to construct something. The robot is sometimes a co-worker. At the beginning, it's obvious that the human will correct it very much because it needs, and so there will be an interaction. The robot has to explain what's going to do. Then, as we move on, we start to get acquainted with each other, and then perhaps the interaction can escalate to a non-verbal level.
Providing explanation, I guess this is what Giovanni was providing before. So explanation in why that plan instead of another one. And,
okay, I think it could help, but we should understand the specific application of this. Not in general. There could be application where, for instance, medical application for sure.
I was thinking something like that.
Yeah, for medical application, giving an explanation of what is due, because it's the same thing that the surgeon does, right? When you operate, you explain to your collaborator what you're doing and why, because in case somebody has to take over, he or she knows what the
why
plan was.
He's doing that way.
In this case, could be helpful. Yes.
Okay. Thanks again, Luigi, for
the
presentation. So now the turn of this is a co-shared presentation, Giuseppe Riccardi and Massimo Zancanaro.
Okay, so the first part of this talk, short talk, I decided to give you 3 insights in what the work we're doing this part of the project, and they go under the general umbrella of conversational AI. And then after this, Massimo will do his part. So what I decided to do, given also what I heard, I was told yesterday, but it's not just you, it's everybody. There are some issues in the way knowledge is transmitted over social media. So pretty much I heard a lot of companies, small companies, research labs are trying to squeeze LLMs into their product workflows, research proposal, whatsoever. And so what I'm going to tell you is about some of the finding and directions we took to investigate further and deep into how generative AI, in particular large language models, could benefit human-machine dialogue. For the rest of you, generative has not to be interpreted in the very evocative term, but actually it's a technical term transformed into a very communicative term, but actually it's autoregressive, causal, left to right, and all that. Anyway, the first question that in my group we've been addressing the last couple of years is, can we rely on large language models to manage knowledge? It's a given, and also you know that Google and others have been trying to use this as a part of their search engine and everything. So the questions that we ask in our group, and this is research led by Mahed, Moussavi, and others, we ask, but what if we really try to treat the LLM as a knowledge repository? So we ask questions, we expect to have the truth, given that we know the truth, and we evaluate this. So that's what he embarked, him and the others, on this problem. And here you'll see, for instance, an example of a query on this entity, Cristiano Ronaldo, asking, what is the current team of Cristiano Ronaldo? And he looked over many, 28 state-of-the-art large language models, expecting to have either the truth or what's the best they could answer, one of the two, okay? Given that the dump they were trained on was the latest, not the latest whatsoever. So he did a very in-depth analysis about how much training data, how the training data that each of these language models could possibly give as an answer. And we found answers that, you don't want to give to your clients when you sell your LLM, whether it's a general or fine-tuned, because if you go and look the paper that he wrote and also the other ones he's working on, you'll find something you want to put under the carpet, okay? There are many things he found out, in particular the consistency of the output of large language models based on input uncertainty, meaning that you would overgenerate semantically equivalent query to get a ground truth answer. And here you'll get a plot from that paper. And you'll see, although instructional models do better, still are not knowledge repository, cannot be trusted. So this is bad news. What I also did, which again I don't have the time to go through, is that there are also some other approaches, I don't know if you're aware of editing knowledge in large language models. Also they fail because most of those works are beyond academic, in the sense that the data set they trained was really bogus. So don't get fooled by editing algorithm, don't get fooled by RAG or over RAG, because that's just a surrogate. So this is one important point. If you want to know more about either read the paper or stalk Mahed. Another aspect we've been working on is reasoning. Again, this is an ongoing predicate being used by marketers, technologists, researchers, unfortunately, that claim reasoning with LLMs. So we embark into figuring out what's good about this claim or what's bad. In particular, when you design human-machine dialogue system, we need to have this ability very well, strong, established, because we have to interact in a linguistic but also multimodal way with these humans, and entities start popping up as you inquiry, and we need to connect temporally, spatially, both. So, for instance, one work that we just published at EMNLP, Bruno et al., looked at even a very narrow problem, but you think this would be solved by the reasoning ability of large language models, which is just to classify through a quaternary problem whether two events were preceding or succeeding. And again, you'll find surprises there, because they cannot tell very well if an event happened before or after, following a passage that we passed to the large language models. Again, this is something that you can go and further get. There is a general debate, again, about this, not only the reasoning, the theory of mind. I mean, it's a nice party discussion or also a business lunch about you can do, but that's just beyond the illusion. For instance, some recent work we're doing, and we're preparing a publication, so I'm told. We're uncovering from the academic perspective that some of the issues in the claims lies in the data and how it's being annotated. And so here you'll see that the blue ones are the true, in other words, model errors, while the orange are the ones due to data annotation errors. So, I mean, if you see this, even visually, forget about the raw numbers, you're saying that your claims about reasoning makes no sense. The last point I want to make, I've been pretty much making since December 2022. The large language model is not a dialogue model. So if any of you has any confidence about what perplexity is or blur, should really go back to the original papers, what this is about, and not use to evaluate your large language model, whether it does good for search or anything. It has nothing to do, okay? And if you maybe buy in your clients, you're gonna have some trouble down the line. And so what we proposed is a contextual dialogue interaction-based human evaluation, which has multiple dimensions, takes into account the interactions, looks at all aspects of interaction which are important, both the semantic part, the discourse part, the pragmatic part, and really gives you a fuller view on what the dialogue is about, how it's going well or not. And this is a paper we published some time ago. I don't see many companies. I don't know how many people are from companies. Oh, wow. Only 2 left. Because the other aspect is that evaluation is very important. Unfortunately, in conferences lately, whether it's a AAAI or EMNLP or ACL or any other, nobody talks about evaluation. But again, when you're going to grab that customer, it's going to ask you about it. And these are recent quotes from Wall Street Journal CIOs, where they're going to do prototypes. Maybe you'll get a POC. In the end, they're going to assess return on investment. And when they're going to ask you for that, they're going to go back to research because you're going to start from research. So that's just a claim that this answer needs to be answered in research. So you start earlier than later. Thank you. And now, Massimo did the right homework because he put the presentation in.
Everybody else. Okay, thank you. I will do this last presentation, I think, so I will try to be as quick as possible. So the idea in human-computer interaction applied to AI is today that there are basically 2 large perspectives on which to see interaction with AI. One is the one just hinted by Giuseppe, that you are talking to an artificial companion, which is almost like a human, but not really like a human. And these are some benefits and also some drawbacks, as Giuseppe argumented. In particular, you have this aspect of social, that encourages social attribution, which sometimes can be really dangerous. The other aspect is to try to build tools, so objects, that are smarter than the normal tools. For example, the very famous Nest thermostat that has been acquired by Google for $3 billion. So there is something beyond that. This is sometimes works better, but there is a problem that there are some opaque mental model from the point of view of the user. So we are not used to work to interact with tools that have their own goals in some way. This is the first time in the history of humanity. I would like to say something about that in particular, because this is some part we work on in the FAIR projects. So one of the things we did in the project is to try to help some colleagues from the University of Bari to try to improve an interface based on classification for rhinocytology. These are nasal cells, something very obscure. But the point is that the system classifies the nasal cells according to some categories, and there is this human that has to check what the machine has done. What we have done actually is try to keep take this system, this interface, and try to apply a user-centered approach, trying to get an understanding, working with physicians. I don't go much on that. You can see the paper there. But what we have done is try to rearrange the idea, the interface in a way that makes more clear and more familiar with the physicians to find the different places and the different aspects. This has been done, largely has been done a usability study, a standard one, but more than that, we try to apply a paradigm of classification, clarification, negotiation, and reconfiguration in a more general way. This is an aspect in which you can merge usability standard interfaces with this new with a new idea of a paradigm that introduce some guidelines in order to improve this. But in general, what I want to focus today is something more peculiar, more specific than that. Is when we change from this idea of interacting with humans to this idea of interacting, which is probably less conceived for a movie in Hollywood, but it's something that for me it would be much closer to the future. I don't want to talk with my machines, something very weird. But I mean, at least conceive me that there is an opportunity also in this way. At least if you trust the $3 billion spent by Google, I mean, there is something beyond. So even if you do this, there is we can inherit 50 or 60 years of graphical user interfaces, and that can be used for the best. But there is also an aspect in which the form that you give to this interaction, actually the form follows the function, as the old Bauhaus motto, but also the form determines the experience, and sometimes in an unexpected way. I would like to give you a couple of examples. One will be very quick because Giovanni already introduced it, is this algorithmic course. Okay, so Giovanni, it's the very same algorithm that Giovanni explores and the very interface. What we did, we tried to build an interface that exactly exploit the powerfulness of their algorithm. So this idea that in a very few steps, taking very few preferences, you can immediately reach the best possible solution. And so the system proposed changes in the plan. So in this case, the idea is that you have to get a master, you have to reduce your request and increase your salary, which is reasonable, in order to get a credit. And then you can express your willingness to take this plan. Perhaps also just go into detail and say, yes, I like more this and less than that. But eventually, what you can do is just, what you have to do is just to keep the plan or ask for a new plan, okay? Because this allows the system to work in a more optimized way. And you have a mathematical proof for that. So they have a mathematical proof for that. And we try to compare this with different paradigms. The one that is used today, this is based on a paper already published, the interface. We redesigned the interface, but basically it's the same. We didn't want to make it very different for the testing purposes. So you have exactly the same plan, but when you don't like a plan, you actually are free to change whatever you want in a very explorative way. So in this case, I say, okay, I don't want to go for a master, but perhaps I can work more hours per week, and so to improve my money. So it will be this equivalent. And so if you do that, and then you ask you do your preferences, and you resubmit your plan. Of course, this is very, very inefficient. And you can prove mathematically that this cannot work, or don't work for the best. So what happened? That our users actually, just to tweak the story short, people actually recognize that the guided interaction improves the efficiency. But actually, they felt much less freedom in doing that. And this sense of freedom was frustrating. On the exploratory interface, there was more anxieties and provide us this sense of freedom, but actually they recognize and they say, oh, in a real life, we probably don't do that. I mean, really a waste of time. We didn't have a statistical evidence because there was just a pilot study that the two actually the experience is different because there are too few subjects. But actually, if you look at how the time they spent on the interface correlates with user experience, in the latter, the more time they spent on the interface, more they feel frustrated. While in the first one, in the guided, more time they spend, they not impact on the perceived efficiency, but also increase attractiveness and perspicuity, so the sense of familiarity and dependability. So I think that these kind of things will prove that having the best interface can be frustrating, but when people realize it improves. So the idea is that just standard usability test cannot work here. We have to reinvent the interaction. I will give you another example about that, even probably more drastic. You know this idea of human oversight from AI Act, so the human should be there in order to be sure, to certify, let's say, the decision of AI. But this is not enough, actually. There is what I like to call the silent killer, like hypertension, is the automation bias. The idea is that people tend to take the suggestion of a computer or of machine learning, in particular when it is wrong. And so we try to do an idea of try to reverse, to combat, to fight this automation bias. And we propose a different paradigm that we call the Socrates paradigm. So the Oracle paradigm is the same one. We use a very strange task. We ask our students to classify birds. Of course, this is an impossible task for most of the students, and we actually we selected those students that did not know anything about birds. And so, of course, this was impossible, but we have an intelligent system, and this is based on an open source visual language model, large visual model. And so the system produced, let's say, a suggestion with a degree of confidence, so the probability of this thing. And then we link to the Wikipedia page. And then the user can ask for the second or the third, so up to 3 suggestions. But then eventually he has to choose one. Okay? And this is the typical Oracle. You have an AI that gives you, oh, this is the answer, then you confirm it. The Socrates is a little bit different. We tell the user, we present the user 3 images that they can be considered most likely more similar. And for each one, we provide the least similar images in that category. Okay? Of course, as an engineer in machine learning, you realize that the system is exactly the same. Okay? It's just the interaction is presented in a different way. An Oracle way, this is the answer, trust me, or not trust me, but this is the answer. The other one is, I make your reasoning about looking for similar things. How do you think that this makes the difference? It's an incredible difference. So we have that the performance have an increase of 30%, very significantly with a very, very high effect size. So it goes from 0.7 to 0.9. And then we have some confusion about the time because the time is a little bit higher, but also the variance is high. So this will probably be investigated more. And we didn't have any big difference in user experience. So there is a lot, again, to study about that. But this idea of imposing a cognitive stops and reflect and helping through the interface to the system to do it, I think that this is the key for this kind of interfaces, at least for the smart tools. So in conclusion, just there are 2 main perspectives. Both will require a human-centered design and don't overestimate. We should not, underestimate the form of the interaction. So thank you.
Okay, so we have time for questions. No questions. Okay, so I think I have a question from Giuseppe and probably also for you, Massimo. The first one is about validation. So make a connection with the previous talk. So having a robotic system that, let's say, translate from the text to a knowledge base and then take a decision on the knowledge base, introduce the problem of that the robot is in the real world. So it's around us. You mentioned about the verification, the validation of LLMs. So can you elaborate a bit more on this and actually on the possible impact on the real world that may have?
So the point about the assessment of large language models as knowledge repository is to assess whether large language models in any way learn about entities as atomic units. And our conclusion with this study was that they don't. So as in real life, this is an issue, because if we have to use large language models, for instance, for a we tried to do a collaboration with Luigi since I came here with language, spoken language, then it's a major issue, because we need to ground our speech with the entities that are in an environment with not necessarily structure. So it's a very important problem, which I hope will get to a point.
Okay. Any other question? So one question from with Massimo. So from what I understood, there is also the way in which you use AI in general can make the difference. So especially when the AI has to interact with humans in the society. So you made the experiment with one user. So what about a community and of people that work or interact with AI? How the complexity can be managed in that case? Because there is a
many person interacting
yes,
among
I mean,
themselves and
yes.
Yeah, of course. Okay. No, of course, in that case, the complexity increases. We have the same problem of automation bias, probably, but also this idea of being aware of what happened to the others. So I think that this part of complexity.
So is there anything that also related human to humans and then human to AI?
I think yes, human to humans take care of themselves, I think. But the idea that you should work for the AI to being aware that there is something else beyond. So if I interact with a group of other person, I have to understand what's going on with the person. There are some interesting studies, not done by me, but by other, in the literature, that, for example, in having an artificial agent interacting with a group of children to study mathematics. And so the children can work among themselves as a group, and the artificial agents in that case was just a face on the screen, but you can think of a robot. And of course, part of the problem was to model the discussion that was going around among the children. And I think that this is really, really fascinating. And of course, it's much, much more complex.
There are works on that?
Yeah, there is some work on that, on this group of users interacting with an AI. Mostly in conversational, I think, as far as I remember.
So in that case, so the AI has to take care about the multi-perspective of the problems?
No, not necessarily. I think that in that case was the case to be a coach for the children.
Yeah, but in general, I mean...
In general, probably, yes. It has to be to have a model of each one, a model of the mind of each one, and probably a model of the status of the group. So you need to model,
so a model of the group.
The groups, yes, the property of the group, who's the leader, how the interaction goes on, and so. Okay. Yeah, I think it's very fascinating, very interesting.
Thank you, both of you, for the presentation. Very interesting. So let me phrase what I think about the difference between Oracle and Socrates. I think with Socrates, you are recognizing the mistake of the model, actually. Because if the model would be perfect, the confidence would give you the right answer. So it's not really an oracle, that one, in the sense that what you do with Socrates, you are actually recognizing images that are not similar to the input, that have high confidence, while you can retrieve another image with less confidence, but is much more similar to the input. So actually what you are doing here, I think, is to recognize when the system is actually making a mistake in the prediction.
No, that's not true. So what we've done is exactly the same aspects. The confidence, okay, in this case is just a fake example, but the confidence is what the probability, so we have the higher probability first. So I think the oracle is the standard situation in this decision-making process. So the system gives its best shot, and in the best shot can be 99% confident or 80% confident. So, but it can be wrong, even with a 90% confidence. But these are exactly the same three that you will say there, but without the confidence, but with the three presented as a similarity.
Yeah, but exactly that is the point. So if I know nothing, I will use the confidence. And so I would pick the wrong prediction as a good prediction, because the confidence is giving me the idea that that is the right. But on the other side, on the Socrates, since you can compare the images, then you can recognize if the prediction that was getting the highest confidence is actually wrong.
Yes, it could be, but for the data is not always the case. There are cases in which the confidence is very high, but the images does not look exactly like that. And so people will look at the.
So then it will be interesting to see how correlates, or how the improvement correlates with the error.
Yes, if I remember, I have to check better the data, but if I remember well, since we manipulated this data, it's not always the same. But yes, you're right, this is something that I have to
just to continue the discussion, it's not like the confidence in that case is given by the system, right? But by the AI.
Yes.
And in that case, it's a human confidence that you are selecting. So you give the freedom to the humans to say, okay, for me this is closer to the.
Yes, but still the point is that if you. But my point was not. It is on the form of interaction. Well, the point is that the form of interaction can change the performance.
Yeah.
This is the point.
That was clear. Yeah. Okay. Thanks.
Giovanni.
Who was first?
Okay, it seems to me that in the last years, some work has been done to make, as you were asking me before, to make a system, AI system, more human-like, even more emotional, fallible, right? Providing you explanation is a kind of display of insecurity somehow, right? I'm not sure, so let's work together in order to encourage collaboration. But these human traits, when you are in front of a computer, are not intimidating because you use your imagination and you can think of whatever you want beyond the screen, right? In some sense. And so you can, but when you have to do with something physical, and as you were saying, we are used to think of physical things as tools, that are extensions of our will, right? Perhaps showing this type of weakness could deteriorate the ability to really collaborate. Because in this case, you see something physical, you want it to be deterministic, etc., because you cannot use your imagination. It's out there, right? You know what it is, you know how it moves. Can you elaborate on that?
Yeah, it's very general. I agree. I think that basically I agree. I'm not sure how far we can go on that, but the point is that there is a lot of evidence that having the system look like a human being as much as possible, so using natural language, using manipulation, to some extent can be useful, at least in some tasks. In other tasks can be annoying, in other tasks can be weird, and in other tasks can be even detrimental. On the other side, having intelligent objects in some cases can be very familiar. For example, in case of Nest, the thermostat is very, very nice. You can set it, and then it learns the habits of your family, and in a few days, it set himself. It's wonderful, but the point is that if something changes in your house, you have to fight with these things that change on themselves. Okay? And so I don't think that there is one is better and the other is worse. It depends on the specific application, the one or the other. But then when we go to the smart tools, we have to reinvent a way to use the tools. Because again, we are not used to tools that do things on themselves. If I switch off the light and the light does not switch off, there is something wrong. For me, there is something wrong in the switcher. There is not something intelligent behind it. But it could be in the future that actually there is something that for some reason the house decided not to switch off. And so how can we better communicate these aspects? We work a little bit on this aspect of decision making that is partially different, but and what is not my assumption, I think it's the assumption generally in HCI today, that the form in which you build your interaction can drastically change the performance, even if the background is the same. So you might be correct that we are suggesting the wrong, but that's exactly the point. Even if it is true, that's exactly the point. The point is that we have to improve our models, our machine learning, our large language model, as much as we can. But then we have to devoid, to give a reasonable amount of research also on the way we present, the way we shape the interaction. Okay, these are just trivial and simple examples. And so in some sense, I agree. Explainability, and again, there is a lot of research, is great in some cases, is completely useless in other, and is even detrimental in other, again. In our study with the doctors, again, that was a pilot study, but some of the physicians tell us, I don't want to see any explanation by the system. Who cares? I mean, I'm the doctor. I take the decision. If the system is wrong, I will change the system. I don't want to wait to read explanations. Yeah, no, I agree. I say that some of them tell us that. Others are not telling that. You're right. It was just an anecdote. It's not a scientific proof.
Very simple question. Yes or no question, like here in the confidence of the eye, are these confidence like calibrated, or they are just like the output of the model? I mean, we can follow up later. I mean,
in our demo, I think that they are just the output. In the user test, we actually we manipulated in order to have the same amount of possible error and things that. So when we presented it to the user, we faked the data in order to have the complexity of the two tasks.
So they're not like really the true output of the model?
Not in the user test. In our demo, I think we actually take the probability, not calibrated. But when we do the user test, we wanted to show some very easy example when we can recognize the bird and the confidence is high. Some example in which you can recognize that the confidence is a little bit lower. Some example in which you don't recognize, so all the possibility, and to have the same calibration on the other side. So we couldn't actually rely on the machine learning to have both tasks the same difficulty.
Okay. Okay, thank you.
I understand your point, but this does not apply to the test. In a real system, that should be, of course, very relevant.
Okay. There is any other comment, question? Let's thank again Massimo and Giuseppe for the presentation. So these two talk close the session, and actually we are at the end of the workshop. Paolo has just arrived for the conclusion. Let me say that actually in this session we saw something very interesting stuff, and I think this will be also increasing the interest when AI has to interact with humans. I think this will have a strong impact on our daily life, and this is something that we should care about. And if the research go in this direction, I think it will be very, very, very interesting. Let me say something about to close, and then I leave you to the final conclusion. So we started the introduction the first day. I was the one that was showing the KPIs, and we say that we are doing quite well and actually impressive about the numbers with respect to the targets that we had. But actually in this 1 day and a half, we saw a lot of very interesting stuff. And actually the debate also was during the session demonstrate that there is a lot of things that is going on. So we have still 1 year, no, right, Paolo, more or less, to conclude the project. I'm really, really interested to see what we will have at the end and actually the future work. That will be more interesting as well. Okay, thanks everybody to have been here, and thanks for all the presentation. And just leave Paolo for the final word to conclude.
No, yeah, thank you very much. I'd like also to thank you all, to thank the university that presented this morning. They are really making our partnership much stronger. To thank, of course, also the company that yesterday had a very interesting discussion about the role in the market. To thank the excellent young researcher that presented, like Giuseppe Riccardi today. And no, we have several younger researchers, and thank you very much for everything. And of course, the third year will be the most interesting because we will have a much larger partnership working with you all to have a big success. Thank you very much. Thank you. La tua provettrice le ha fatto 24.000 domande.